yesterday. Okay, now important thing for today, we need to understand how to build this payment integration system. Think like coders, think like developers. Okay, so we are going to get into technical exploration. Okay, how exactly we can build this payment integration system? Nothing but this box. Okay, now we need to understand there is a concept in the IT industry whenever we are about to start to build a project, and that concept is what is the project architecture. Okay, so first step is always going to be choose the project architecture. And there are multiple types of architectures in the market. Okay, first of all, what is a project architecture? So we need to understand, okay, whenever you build a project, let's say you want to build this kind of a project, payment integration system. You know, even with your JDBC level knowledge, let's say some of you are aware of JDBC. So we know that you write your, let's say, Java application. It needs to connect with database. So what is happening? Already for your project, two different systems are there. One is your Java application, another one is your database. Okay, DB. As you start growing more in the IT industry, you will realize, like database now, many other services might be available. So we can call this Java as one service, this database as another service. These are all softwares, right? Now, in future, more and more, as you learn more things about the IT industry, more features you understand, you will realize there will be something else, let's say, called as what? A caching service. Some of you might already be aware of this. Okay, some caching service like Redis. There are multiple caches in the market. Redis is one of the example. Okay, next, you might know about, there is another service which could be possible, which is nothing but Kafka. Okay, Kafka kind of service, or ActiveMQ, or RabbitMQ, or Amazon SQS. These are multiple services which is having a special need in the IT industry. Now, what is happening? Just observe these all services. How do they interact with one another in the right manner? That basically forms an architecture. That is where we need some project architecture. So every project is going to have a lot of pieces of software. How they all interact with each other, for which feature, what are we supposed to use? Designing that properly is nothing but architecture. And also, when you are writing the code here in Java, so how do you really write that? Should you write everything together, or should you break down this one Java code into two parts and write it separately? All that is also part of the architecture. So please understand, whenever you start building any project, step one question will always be, okay, what kind of architecture approach we want to follow? And architecture approach is nothing but you need to be aware for your project, multiple pieces of softwares will be there. Okay, how exactly they will be interacting with one another. Okay, next, when you're writing your Java code, should you write everything together, or should you split it into multiple other code pieces? All that decision is nothing but architectural decision. So let us write down few bullet points about it. Okay, for starting any project, we need to decide how all software pieces of the project will interact with one another. Also, second, how should you write your entire, let's say, Java code? Everything in one place, or split the project code into smaller pieces. Okay, All this decision making is nothing but, okay, what should be your project architecture? Now, in the market, multiple types of project architectures are available. Types of architectures. And this is evolved over a period of past 20, 30 years. Okay. So what is that? The first type of architecture, we can say monolith architecture. The second type of architecture, we can say SOA, service oriented architecture. All these are very basics. I think many of you might be aware of it, but just recap, see where what things get positioned. For some of you, this might be new. So no problem, focus and understand. So this is what, whenever you want to start any project development, you need to choose an architecture. And in the market, in the IT industry, many types of architectures are there. What is an architecture? How does the software interact with each other? When you're writing your Java code, should you write everything together? Or should you split it into different pieces? Making those decisions, architectures are going to help you for that. And now there are multiple types of architecture in the market. One is monolith architecture. Next, service-oriented architecture. Okay. Next, microservice architecture. Okay. Next, nowadays, since past some time now, there are other type of architecture also called as modular monolith. So even people are preferring to use modular monolith also in the current times. And modular monolith is further extended to even become a modulith. So they took the modular monolith and they applied some more standards on top of that, and they are now calling as modulith. So please be aware, in the IT industry, different projects might follow different architectural style. So these types of architecture, people might also call it as architectural styles of application. Okay, monolith, service-oriented architecture, microservice architecture, modular monolith architecture, and modulith architecture. So don't think that these guys are old. So monolith came long time ago, but these are also some popular styles even in the current application development. People are even choosing to go ahead with this. There are seeing there are some problems with microservice, so we need to even use these kind of systems. So there is a kind of discussions happening in the industry. But yes, for our project, we will be focusing on microservice-based architecture because it is something now very commonly used. It is a common term that people use on a day-to-day basis, and you need to be aware because this is something really very popular in the current times. And generally, for Java, for developing microservice, Spring Boot is always the first choice. So microservice with Spring Boot becomes the very first choice. Now, you need to understand, we don't want to get into details about all this because we are going to discuss everything practically. It's about project development. So we will focus on things which are essential. Okay. So one liner, if you want to say, what is monolith? Think about it. We want to develop this payment integration system. We want to develop this payment integration system. One approach can be, let's develop everything as one big project and run it in the system. Means whatever Java code you want to write, put everything together and execute the system. That approach is monolith approach. It even includes front end also code you can put here, back end code you can put here of the entire project. So that is monolith. Entire code you do together. Okay, there are a lot of problems with that. Let's not get into the problems, but this was the very old model when the IT was in the very beginning state. And then people realized so much of code, everything is coming together. The amount of time taken to compile this entire code, build it, deploy it, restart services, everything was very painful with traditional monolith kind of system. And then people started saying, we need a better architecture. And that is where service-oriented architecture came into picture. SOA. What they said in service-oriented architecture. Okay, don't develop everything together. Rather, break down your project into smaller pieces. So break down your project into smaller pieces and run every piece separately. So now instead of one big project, now you will have 4 smaller projects. That is where the concept of services came in picture. With service-oriented architecture, this concept was launched. And yeah, so it initially started a very good idea. People were liking it a lot. But very soon, problems started coming in service-oriented architecture. So what was it? Don't develop everything in one big project. Rather, break it into smaller parts and run these parts separately as services. Each part they are calling a service. That is where service-oriented architecture. So the basic concept was very good and people started liking it a lot. But very soon, a lot of problems came with service-oriented architecture. Okay. Okay, what kind of problems? Many people started using when one part is trying to communicate to another part, a lot of people started using something like XML-based approach. Next, as the industry evolved, they introduced another new component called as ESB, Enterprise Service Bus. Enterprise Service Bus. And they said whenever communication between two parties should happen, they should first talk to ESB, and then ESB is going to talk to other service. So they started introducing ESBs, Enterprise Service Bus. And then they started, okay, you can write more logic in ESBs. And then in the market, many software companies came and they gave their own, some open source ESBs were there, some paid ESBs were there, and which is having a lot of logic. Okay. Third problem, in service-oriented architecture, people were not having clarity, no clarity of what exactly needs to be done for being a successful service-oriented architecture. Means what people were doing, developers were doing whatever they want and saying it is a service-oriented architecture. There was no clear definition, what exactly is a service-oriented architecture. Different people, different companies, they were following whatever they want. So these things became really very bad for the industry. This ESBs, introduction of ESB, they become so heavy that for maintaining the entire project, there is a lot of cost gone into ESB for maintenance, for setting it up, for writing the code there. Then XML was very heavy for communication. And then people started realizing there is no proper clarity about service-oriented architecture. And then people really started hating. And some of them said, rather than doing this kind of mess, let's go back to monolith style itself. So observe, industry is a very smart industry. They want to improve. Human beings are smart. We want to improve. But how it happens? First, if this approach was there, then they tried to improve this one. And then it was a problem. Then what people said is, we need a better architecture. And that is where microservice came into picture. So what they did, they took the basic concept of service-oriented architecture and they learned, okay, what are the main problems there? And they tried to solve those main problems. Okay, so the core, okay, they got inspired from service-oriented architecture, removed all major challenges and added new disciplines. And then microservice architecture was formed. So some new best practices they added. They solved the problems of that. And then this came into picture, microservices. Okay. Now, how exactly, who did all this work? So there were some architects around the year 2014 or something around that. There were two architects like Martin Fowler and James Lewis. What they started saying is, Okay, people started discussing this microservice and saying, okay, it's better than service-oriented architecture, and this can happen, that can happen. But if you ask people about clarity, okay, what exactly is microservice? There was confusion. You talk to 100 people, and they might have some different answers. So what these two architects they did, they were really technical experts, and they analyzed if there is no clear definition of what exactly is a microservice, then the way service-oriented architecture become confused and unusable, microservice will also become like that. So these guys took the responsibility of defining initially 9 principles or attributes of microservice. What exactly these 9 principles or attributes is that if your project wants to implement a microservice architecture, you should try to implement as maximum of these 9 principles. And now there are some list of principles which comes along with it. And then they defined one definition about this microservice. Okay, so I'm going to share you these notes as well. So there is a note already yesterday in the WhatsApp group. I shared you this session material V1 related reference, right? All the session recordings. So guys, you just need to have access to this session material V1. Here you can find everything. So yesterday, whatever session we took, it is available here. So you can check it out. So like looks like forum members are already sitting here. So on a daily basis, whenever we are doing the session, it is going to be available. The recording, the notes of that day, whatever I type in this notepad, that notes will be there. The diagrams, whatever we are drawing on a daily basis, in the notes, those diagrams will be available. So whatever I am doing right now today also, they all will be highlighted in the diagrams as well. Okay. And then attendance for that day. Next, whatever links that we refer throughout the today's session, those links also on a daily basis, it will be updated. Today's session will also be coming here. Next, all the live notes, notepad notes are arranged in one folder at this place. And any other document that we will be adding will be added under this only. Okay. So if anybody of you is not having this, so please join the WhatsApp group. There we are daily sharing the details. Okay. So please join this group if anybody is not in any of our WhatsApp groups. Okay. Fine. Let's go. Let's go. Okay. Fine. Now let's continue back. So what are we saying about microservice? Guys, focus on every single thing, whether you know it or not does not matter. Focus on the basics. Basic needs to be very clear. So I'm going to share with you guys one simple document which I have created, basically some screenshots. Microservice architecture. Let's just walk through it to really understand this core stuff. Okay, so no need to get into all this discussion because it is a complete 3 hours topic to discuss microservice itself. We are not going to do that today. Today, I am just introducing the architectural style for you. What you need to understand is this one. This is Martin Fowler. This is James Lewis. Common characteristics of this architectural style means if you're developing project using microservices concept, then these guys have defined some around 9 principles. And then over a period of past 10 years, some more additions have happened, but the core concept is the same, which everybody should understand. And this guy, Martin Fowler, they have given some nice, on his website, this guy has published, on his website, this guy has published the definition of microservice and furthermore, these 9 attributes and some comparisons with multiple models that guy has published here. And if you go to this second link, all these 9 attributes are also explained here. So you can spend some time in understanding through this. Okay. So these two guys, some description about them, plus each of the attribute with some diagrams and definitions. Okay. So componentization via service, organized around business capability. We are going to discuss this as part of week number 2, not today. Today, our focus is to understand it in a wider perspective, where what fits in when project development happens. But the conclusion you need to understand from this place is something like this. Late in 2013, okay, discussion started happening. So this is written by Martin Fowler on his website. I've just taken a screenshot. Late in 2013, discussion started happening about microservices, and this guy became really concerned that there was no clear definition of microservice. So people were not having a full clarity of what is a microservice, and similar problem were faced for service-oriented architecture also. So this Martin Luther came together to work with James Lewis, who was one of the most experienced practitioner of this style, and together we wrote this kind of a paper where they have published these 9 attributes. We wrote the article to provide a firm definition of microservices style, which we did by listening to the common characteristics of microservice architecture that we saw in the field. So they interviewed a lot of people, discussed on a lot of projects, what is going on, plus they applied their own expertise, and then they came, okay, if you want to say some project is a microservice based project, then these kind of attributes, as maximum of these attributes, they should try to follow. Sometimes maybe all 9, sometimes even 6, 7 happening, then also it is a microservice architecture. But try to do as many as you can. This is what is their proposal. Okay, and based upon these 9 attributes, they have summarized a 1-paragraph definition of microservice, which is this. We are not going to get into too much details about this. We'll understand only basic today. Okay, what did they say about microservice? Microservice architectural style is an approach to develop a single application as a suite of smaller services. So one application you want to develop a suite of smaller services, means many smaller services, each running in its own process. Nothing but when you go to your Windows Task Manager, everything is a separate process, right? Chrome or whatever WhatsApp app you might be using. So everything is a separate process. Like that, your Java project should be split into many smaller services, and each service should run as a separate process in itself. Okay. Next, communicating with a lightweight mechanism and common practices over HTTP protocol using APIs. Okay. And then the second definition, the second part of this definition adds more technical information to it. These services are built around business capability, independently deployable, full-on automation will be there, bare minimum centralized management should be there, can be implemented in any programming language, and can use different kind of data storage technologies. Nothing but you can write microservices in Java, Python, Golang. So it is an architectural style, not specific to Java related people. So you can implement microservice based architecture in whatever programming language. You can choose any kind of database, SQL, NoSQL, and multiple types of database. And then there are guidelines about how this everything should be. For now, not required to go in this. You will get it full clarity once we discuss these 9 attributes, which is a 3 hours topic in itself. So not today, some other day. In week 2, we will be discussing that. But today you need to understand at least the initial part of this, which is again inspired by service-oriented architecture, but they further refined it. So what microservices say? Okay, microservice architecture firstly says, don't develop entire project as one big piece. Okay, so let's say if this is your entire project that you want to do, this is your entire project code. So microservice is saying, okay, don't develop everything together. Rather, you split your project into smaller components. How to split this into components? Okay, they have given some principle for that, organized around business capability. Split the project based upon some business capability. Nothing but related functionality, you keep it together in one part. And that is what it is. Anyways, no need to get right now, just understand this. Don't develop everything as one big project. Rather, split it into smaller pieces and run them separately as processes. Nothing but when you're running a Chrome, let's say in the task manager, when you go, okay, in the task manager, when you go, observe every process occupies some memory. It is working with the disk. It will occupy some network. Means every process is independent from one another. It has its own memory. It occupies some portion of the CPU. So that is how each microservice should also be there. Everything running as a separate process. So that is what simple approach. So what they said was, okay, don't do everything together. Split it into smaller services. So let's say this is going to be service 1, this is going to be service 2, this is going to be service 3. And run these services as separate processes. Nothing but it will occupy its own memory. If you know some server concept, so it will occupy its own port also. No need to get into the port right now. We will discuss it later. But please be aware, run them as separate processes. Now, there are multiple rules here. How do you split this project into smaller services and all? So for that, we will again discuss it in next week. Right now, you should just understand is something like this. Microservice is nothing but, okay, split your project into smaller components. Okay, these components are called as services. They should be executed independently as separate processes. For now, understand only this much. They should just be operated separately. How it is going to be technically achieved, today we are going to set up our first Spring Boot application. Then you will understand. Using Spring Boot application, we will be building our first microservice today itself. So you will get the clarity by the end of today's session. But right now, this is what you need to understand. Don't develop everything together. Split it into components and run them separately. What does it mean to run them separately? Okay, today practically we will do, then you will understand that point. Okay. Second thing, what as per the definition it continues, communicating with a lightweight mechanism, generally simply HTTP call. Okay. So now comes the question. If the entire project is split into many pieces and they're running separately, okay, let's say you write one method here and one method is here. If you want to access that method logic here, how are you going to do that? So they said lightweight mechanism should be there, generally an API call over HTTP protocol. What is API call? What is HTTP protocol? Okay, we will understand. For now, at least can you understand this point? Okay, two services can talk to each other using concept of API calls and over the protocol HTTP. We know that everything web is basically connecting via HTTP protocol. So whenever you go, let's say even this URL, if you're taking, right, it is a HTTP protocol. So this is a very common protocol style for communication. So these microservices should also communicate with lightweight protocol, generally HTTP itself. Okay, so use HTTP protocol for communication and they will communicate via APIs. Okay, for now, just understand this much. For now, just understand this much. API full form, I think people know it, right? Application Programming Interface. For now, you should just understand this much. Whenever you have written any method here, if you want this method should be invoked by outer people, you need to give it as a web API. For now, only understand this. Okay, for now, only understand this definition. If service 2 wants its method to be called by other services, then the method needs to be exposed as a web API. That's it. API is two technical systems can connect with each other. So technical definition of API is it's like application programming interface, but basically two applications can connect with each other. That is simply called as API. When they connect with each other in a web style, what is a web style? Nothing but using HTTP protocol. So when the connection is happening in a web style HTTP protocol, they are called as web APIs, or even, guys, you might have heard this term called as web services. So API means two parts of the system can connect to each other. When they are connecting over web, nothing but using HTTP protocol, they can be called as web APIs or web services. So now this is the second part. The first part is microservice ka first part is break project into smaller pieces and run separately as process. That is first thing. Second thing is how these services can communicate with each other, and they are saying make it like web APIs or web services or APIs over HTTP. This is what people will use the term. How these services can communicate with each other. These are the mechanisms for that. Okay. And now if you go further, how do you develop these kind of web services? Web APIs, web services, APIs over HTTP. How do you develop that? Then there are standards for developing web APIs. And the popular standards are nothing but REST standards. REST standards. Standards are nothing but guidelines, rules. REST standards for developing a web API. Another one is nothing but SOAP standard. These two are some popular ones, but since many years, SOAP is not utilized in the current time. Majority of the projects are going ahead with REST related standards for API development. And if you really look for PayPal yesterday, we realize PayPal is also following REST API. So what can we understand? You got multiple terminologies right now. Two systems can communicate with each other using API. You need to be clear on the basics. Two systems can communicate with each other using API. When it is happening over HTTP, we can say it is a web API or web service or API over HTTP. Next, there are standards of developing these APIs. Those standards are popular two styles: REST related standards, SOAP related standards. But SOAP is now not commonly used. Majority of the projects are using REST related standards. And when you use REST standards for developing web APIs, we call it as REST APIs or RESTful web services. These all terms are basically talking about this clarity which we discussed right now. So guys, you're getting the perspective where what fits, right? What is an API? What is a web API or web service? And then what are the standards of REST? What are the standards of SOAP? What those standards are, again, part of week 2 discussion. Right now, just understand there are some guidelines. There are some standards defined. What those standards are, we will discuss it later. And yes, when you follow these standards, you basically build REST API, RESTful web service. Okay, fine. Guys, whatever we discussed so far, is it all clear? Please quickly mark your understanding score. I will keep repeating. We will keep summarizing in between, guys. Okay, so let's start. Please share your understanding score. Let's say 5. And I'm telling you today, a lot of technical things will be discussed. In the beginning itself, we saw, right, 50% people are knowing Spring Boot, 50% are not. But today's session is going to be useful for all entry-level people. Whether you know or not, you will get a clear-cut clarity about what is what. Okay, we are going to discuss everything practical. Fine. Let's continue further. Very good. Based upon the current observations of the members, 250 members voted. We see around more than 90% is having strong understanding. That is super. Okay. So all the guys who are having strong understanding, today after the session, you should further explore on internet and prepare yourself. Okay, you can explain these concepts during interview. That much you have to do. That will be a stamp on your knowledge. Means anybody discusses all these things, you do your research on ChatGPT, internet, draw your conclusion, and then confidently present that knowledge in your resume and during interview also. And all the people who are getting not 5s and 4s, means you need to watch the full session again and work double hard than people having 5 and 4. That is how you can be in the race. Please note that the market will hire only good people. Rest of them will be discarded. Your effort for everyone should be, how do you belong in that good people category, which is only top 20%. You need to belong in top 20% of job seekers, because selection is going to happen only there. Rest of the people will stay crying, complaining, blaming, and they will not be getting the job. So only good guys will get it. So belong into this category so that success and results come to you. Okay, fine. Let's continue back with our topic. Okay, very good to see. Around 400 members have voted. 94% is 5 and 4. That is great. So you guys are smart. You need to know that. You need to believe in that. You're smart. You're intelligent. Just with slight guidance, if you work on yourself, extraordinary results can happen. And yes, once you believe it, start working on that, you will get amazing success, guys. Okay, fine. Let's continue further. So so microservice we have launched. Now remaining to what is modular monolith, what is monolith. Out of your own curiosity, you can now play around with ChatGPT, go to YouTube and find it out, figure it out, read about it, build your own understanding. But yeah, in our project, then they're going to take the full application and split into multiple microservices. How these services will be built, it depends upon logic. Currently, I am just giving you the names. We will have 3 microservices. One is validation service, payment validation service, payment processing service, and PayPal provider service. These will be the 3 microservices which we will use. Payment validation service. This is payment processing service. And this is PayPal provider service. And there is going to be communication between this. What is the responsibility of each of the service? All that we will discuss as part of next week when we discuss domain and architecture style, and then the rest of the concepts will follow. But for now, just be aware, our entire project, we will develop it as microservices. That basically means break down your project into smaller services. Each service will have certain responsibility, and fine, and everything should be running as a separate process. And they should communicate with each other using some web APIs concept. We will be using REST APIs for communication. So the way PayPal has given REST APIs, internally, when our services communicate also, we will do it via REST APIs. Similarly, here also, REST API based communication will be there. Okay, fine. So chalo, this much of decision is done. Okay, now comes the next topic. So let's say you have finalized that we need to build microservices. Every service, smaller service, having some decent amount of code, and now it can run by itself. Okay, now comes the question, how do you code into this service? How do you really build this service? What should be your coding approach in this service? There are some things you need to understand about that also. So whenever you are building the project, the first question you need to answer it, what is the project's architecture or architecture style? And now we are saying microservices are project architecture style. Now, next question comes in picture. How do you develop each microservice? Are there any guidelines for that? Yes, there are guidelines. And again, For developing each microservice, now there is one guideline given. There is another architectural style. So one is project level architecture. Another one is service level architecture. This is service level. Means if you want to develop one microservice, let's say this one, how are you going to do coding in that? For that also, they have defined an architectural style. Okay, nothing but how to do coding, how to code in each microservice. For that also, architectural style is there. One common and popular architecture style is layered architecture. Layered architecture, I think you will be knowing it, but be aware, project level architecture means applies for entire project. Then when one service we are discussing, how do you code in this service? That is where we need service level architectural style, which is nothing but layered architecture, which simply says, okay, when you're doing now coding, let's say you build this processing service. Let's say you build this processing service, payment processing service. So let's say when you build this payment processing service, how should you code in this service? Okay, for that, layered architecture approach is there, which says you need to code in layers. Layers are like controller layer, service layer, DAO or repository layer. Next, there is another term, model layer. Okay, there could be some other term, integration layer. Nothing but when you are doing the coding, you need to write it in multiple layers. For now, just understand this. Okay, when you're doing the coding, different types of code will be there. So what is it? When you're doing coding, different type of code will be there. What are different types of code? Okay, nothing but there will be something like presentation logic. Presentation logic. Okay, there will be something like business logic. There will be something like database logic, working with database or persistence logic. There will be something like, in order to pass data from one layer to another, you would need some data to be passed from one class to another class. Next, you want to make external, let's say, REST API call. All these are different types of logic. Presentation means this about the view part. Business logic is about the core logic of the system, the business functionality. Database logic is like working with the database. You need to pass data from one layer to another. So that is another different kind of logic. You need to make external REST API call. Different kind of logic will be there. Now, point is, people realize when you are doing coding, these many type of logics could be there. If you don't do it properly, it will again become a mess. That is where layered architectural style is there, which simply says the right kind of logic should be written inside the right layer. So controller layer is going to deal with entry level logic and also presentation logic. If you are having a front end code with you, so presentation logic, entry level logic will be available here. Okay, what is meaning of entry level logic? Entry level logic from diagram, just simply understand when one microservice is trying to call to another microservice. So this entry, nothing but others should be able to call you. That logic is called as entry level logic. Means because of this controller itself, other people will be able to call your service. If there is no controller layer, nobody can connect with you. So that is entry level logic. Okay, you have written some function, you have written some method. You want that this method should be called by outer people. How do you do that? That logic is controller logic or entry level logic. So we can simply put it something here. Okay, we can simply put it here. Because of controller layer logic, external services can call our system. If you have not written this controller layer logic, other guys cannot really reach out to you. So there is special type of logic required for this purpose. For now, just understand, if there is no controller layer logic, other services will not be able to call you. This much you need to understand. So if you want that your functionality should be called by other people, you need to write some controller layer logic, nothing but entry layer logic. It is a kind of business logic. It is a kind of logic that we will write. Okay, some annotations will be there. How to do that? Everything one by one. Today we are just putting the entire technical project in perspective. And juniors don't know this. And then they are saying, give us job. But you're not ready because you don't know how projects are built up. That is where company is saying, when you're in college, do internships, work with some real-time projects so that you gain more knowledge. Okay, you know this thing, just go to internet and you will find almost majority of the students who complete the college is not ready to work in the industry. This is a publicly statement, everybody knows it. So point is, you should solve that problem, not cry about it. My college did like this to me. No, everything is available on internet. Everything is available on internet. AI is making it more accessible. So for how long you will sit and cry and complain? So complaining is not an option. If there is a problem, solve it. Grow your knowledge, become ready, become capable. The world will respect you. They will value you. They will give you whatever you want in return, right? So become valuable. Automatically your success will come. Don't sit and cry and blame. Those people will never go anywhere with their lives, right? Okay, very good. Now, so this is kind of logic is controller level logic, entry level. Because of controller layer only, other people will be able to call you. So all that logic, entry level logic, which allows other systems to call you, we will put that inside controller layer. Next, all your business logic, we will put it here. Your actual business logic, we will be putting it here. Next, when you want to work with database, we will write the database logic here. For example, JDBC you are aware of, or let's say you're aware of JPA, or you're aware of, let's say, Hibernate, or any other DB style of coding. It all goes as part of this. Or let's say Spring JDBC is available. It all belongs as part of this layer. So core business logic will go here. If you're working with database, select star from, insert into, updating, deleting, whatever DB logic you say, okay, we will be doing it here. Okay, model, right now just understand model means passing data. Model represents data. For now, I'm not going to explain it because you need to practically look at the project. Then you will understand model clearly. Right now, even if you try to explain, it will add confusion, not required. Model right now, you just understand it is data. Data is nothing but Java object. People can call it as a POJO object, just having fields and getter setter. That kind of objects, we can say it is a model, means Java objects which can only hold data. And we will need this object throughout the project. So that is what we can say model layer. Integration layer is where you integrate with external services. Now, based upon this, today's conversation itself, maybe what we did in the past 15 minutes, you should understand IT means clarity. If there is no clarity, projects are going to fail. Think about it, right? If there is no architectural style like microservice or anything, how are you going to really build a system? No, guidelines are required. That is where architectures are there. So first we decided, oh, we will be following a microservice based architecture, which simply says, take the project, break it down into smaller services. They should communicate over a lightweight protocol like REST over HTTP, REST API call. Okay, very good. Now, second question, how do you develop every microservice? Different types of logic is there. Presentation logic or entry level logic, business logic, database logic, model layer related, integration layer related. If there is no standard for that, again, everything becomes a mess. So IT has come up with its own systems to better build applications. And that is where layered architecture is coming in picture. Layered architecture. What is a layered architecture? Okay, right type of business logic, you write it under proper layer. So what are the layers? Controller layer, service layer, DAO or repository layer. DAO is data access layer, and then model layer and integration layer. Okay, fine. Okay. Next question comes. Okay, now think about it from technical implementation. How to code each of the layer? It is very simple. The answer is very simple. How to code each of the layer? Okay, the answer is so simple. You already know it. Using the concept of packages in Java, right from the beginning, you are writing packages, right? Package, and then you put some package name, com dot mycom dot something, right? So using packages, you can write your layers. Okay, for example, we can put one layer called as your package. Let's say you will put how this package naming is happening. We will discuss that separately, but just know it for now. You will simply create a package like this, com dot mycom dot controller, and here all controller logic you will write. Package can have sub packages also, controller dot something, you can do that, but at a high level, com.mycom.controller, all controller logic will go here. Similarly, you will do something like this, com.mycom.service, all service logic is going to go here. Next, you can put something like repository, or you can say something like DAO. Here all the database logic is going to go. Next, for model also it is going to be there, for integration also it is going to be there. The point that I am trying to make here is, using the concept of package, we can create this. Using the concept of package. And then inside these packages, you will write your Java classes where that kind of code is going to be there. So in core Java, you already know how to write classes, methods, and all that drama. But yeah, we need to do it in right packages. And how do you define the package? Based upon the layered approach, you will just arrange all these things together. We will take a separate session on packaging styles. What are the common packages that people will need? Again, separate talk. One by one, we are opening the box of technical knowledge. Okay. So guys, what have we discussed so far, right from the beginning of the session, that we want to implement? Everybody please focus. We want to implement PayPal integration system. Okay. For that, how we are going to do? We need microservice style of application. Next, how we develop each microservice. Okay, we need layered architecture style for that. Layered architecture style for that. And how do you develop? How do you develop layers in code? Okay, for that you need to simply use Java ka packaging concept. In the right packages, put the right classes. Okay, you're done as per layer. But it is important to think which class should go in which packages, right? So that is what using packages. So this is how simple things. We are converting concept into now technicality. So please focus on that part. Okay, fine. Now, next important point, very important point, guys. Please put your entire attention on this one. The next 10 minutes are very important. Please put your full attention, because beginners who don't have knowledge about frameworks, for them it is full new topic. So please understand. Okay. Now let's say we want to now develop one of the microservice. So we understood layered application, but we want to develop one microservice. Okay. Let's say, for example, yesterday PayPal itself said, right, okay, your merchant server. What did PayPal say yesterday? We will just put it into diagram. PayPal said this, okay, there is going to be a merchant server as per their terminologies, and there is going to be this PayPal system on the other side, and there is going to be some merchant page, nothing but merchant front-end application. Front-end application or page. And as per their sequence diagram, they said the front end calls merchant server. Merchant server should call PayPal and then take the response and give it back. Okay. And then we further split that this merchant server is going to be basically two systems. It's not one. Merchant server is actually going to be, from our perspective, we will say this is the actual merchant. This is the actual merchant. And then we have our project in between. So which is going to have now multiple microservice. And the communication is going to go something like this. Their front end is going to talk to their backend. Their front end talks to their backend. Their backend talks to our microservice. And then we talk, and then response comes, and then we get it back, and then we give it back. This is how the communication is, right? Okay. Now, please understand, we will write some kind of logic here to achieve this entire aim. So let's say you know simple core Java. Okay. Understand this part very clearly, guys. You know simple core Java, how to write application in core Java, right? So you will do, let's say, class, my class. And you will write certain method, object-oriented programming style. Let's say make API call to PayPal. And here you will have all the business logic required for making whatever data so that you can call PayPal. And then you will use maybe integration layer and then call the PayPal system. Okay, whatever. But just imagine you have written a method. Okay. And this method is having the business logic to talk to the PayPal system. Okay, that is fine. But now comes the point, okay, these guys should be able to call you. Please understand, it is a web call, web API call, nothing but over HTTP protocol. Now, how do you give this functionality so that it can be accessed over web? Please understand, if you're doing coding using simple core Java application, your application cannot be accessed via internet. Simple core Java projects that you do cannot be accessed via internet. Now, we have written a method. We want that this method should be accessed via internet. In order to do this, it's not going to be easy. You need to learn how to work with networking concept, how to work with input-output streams concept, how to work with web-related concepts. It's all very different game altogether. You know how to write this functionality, but in order to make it a web API, you need to learn a lot of other concepts and you have to code that many number of concepts. Only when you do this code, then people can access from outside. Okay, so let's try to draw some conclusions here. Using simple core Java application, whatever methods you write, you can access it only standalone, basically, right? Standalone application. If you want your method to be accessed standalone from same machine, if you want your method to be accessed across web, nothing but internet, via HTTP protocol, then you need to write more code using networking, IO, etc. concepts. Now, just imagine developers are hired to do basically this work. Now, you will take so much time to understand all this, code all this, and IT industry is not going to be successful. If for every project, everybody is supposed to learn all these things, work upon all these things, means projects will take maybe double time or even more for completion. So IT has gone with a smarter way. What is that smarter way? Okay, we will not be writing this kind of logic. We will not be writing this logic. Okay, we will use existing written logic here. Nothing but how the IT industry has evolved. In the world, somebody has already written this kind of logic. So in the world somewhere, okay, all this networking logic is already written to make your application a web application. This logic, nothing but code for this, is already written. What you will do as a smart developer, you will not try to write it by yourself. You will rather take this code and put it in your project and get that power. It is that simple. I'm taking one specific example so that you can understand. It is much more than that, but I'm taking one specific example so it becomes really clear for you. What is that example? Okay, you have written business logic, and now external guy is supposed to call that logic. In order to do that, you need to learn and work with all these concepts. It is going to take maybe double time, and you might make mistakes there. You have to fix bugs. Testing is also going to take more time. And this is something which all the projects of the world needs, right? Because majority projects are web-based projects now. Across internet, from the websites, people can access it. Now, when it is a web-based project, every company of the world, every team of the world has to do that development. So better not do it. How about one common way? One person of the world has built this kind of code, which is nicely tested and working and everything. And now all the rest of the world simply uses that code and makes it a web application. How smart that approach is. Take a moment to think about that. Something which the world needs. So we are not going to develop it. Somebody else has developed it and made it available. Okay, that is how it works. Now, how exactly that is going to happen? This code that we see, that terminology is nothing but framework code. Frameworks. These are something called as frameworks. Okay, and the popular frameworks in the market is Spring and Spring Boot. For Java related people, these are the popular frameworks in the market. There are several other frameworks also, but for now, if Java means, these two things you are supposed to be aware of. Okay, so please be aware of that. So very softly we have introduced the term framework. Don't get confused. Framework means somebody has done the coding already. It has lot of features, lot of capability, and it is already coded, already tested. We just need to take it, put it into our project, and life is jingalala. That is what is a framework. Okay, so that is how simple things are. You need to understand it very clearly. Framework is not complex. Spring Boot not complex. It is simple. Somebody else has done some coding which gives special power to your application. You need to take it and you need to apply it here. Before we go further, let's write down our conclusion. Okay, using core Java, you build standalone application. If you want to make it like this, you need to write more code. So, okay, so we as developer don't want to spend time in writing this networking related code. Rather, we need some reusable code for that. Okay, this reusable code is already done in framework. Some set of people have developed frameworks which have huge pre-written business logic. Okay, you can take this framework logic and add to your project, and you will gain that feature capability. Take a minute to just understand this. This reusable code, we need to have some reusable code. This reusable code is already done by the framework team. Okay, some set of people have developed frameworks with having like huge pre-written business logic, and you can take this framework logic, add it to your project, and you will gain that capability. Okay, so in simple words, if you want to define a framework, you can say, okay, it is pre-written reusable code, okay, when added to your project gives you more capability. So you don't have to double write it. Pre-written reusable code when added to your project gives you more capability. For our case, okay, we can make our standalone application into a web application using framework. This is one example, using framework. And like this, framework can be used for a lot of other applications also. This is one of the example, and the popular frameworks in the Java related world is Spring and Spring Boot. Okay, nowadays whatever projects which start in Java, they use Spring Boot itself for building an application. And now you need to understand, Spring Boot internally uses all core concepts of Spring. So point is, you cannot learn Spring Boot if you don't know the core concepts of Spring, because it is used. Okay, even for coding wise, you need to be aware of Spring core concepts. So you cannot directly go to Spring Boot. Your approach of learning will always be, what are the core concepts of Spring? You need to first understand that, because during coding in Spring Boot, you will need that also. Okay, okay, fine. We will get into those details more and more. But for now, just understand, somebody in the real world have built frameworks which is having a lot of logic, and this logic is already written, coded, tested, and working fine. You will just take that code, put it into your project, and get a special behavior. That is how frameworks are. Okay, now comes the next question. How do you take the code from these people? How to take code from these people and add to your project? How to do that? So that is where comes the concept of jar files, right? You might have worked with jar files. So what is going to happen? Whatever code they have written, they will be putting it into jar. Let's say myfile.jar. Jar is nothing but, you can assume, archive file, zip file. The way zip files are available, like that jar file is available. Okay, and this jar file is nothing but all the code whichever these people have written. Basically, it will be compiled and then jar will be prepared. But that code is going to be put into jar file, and this jar file you will be taking in your project. Okay, this jar file you will be taking in your project, and that's it. You don't have to write all this. You just need this jar, because it is already written and you're able to work with it. Okay, please understand. Next point that we will discuss. So here, what are we saying? Jar file. Okay, the framework code can be added to your project using jar file. Now you have to understand other things here. In framework, now they might do a lot of coding. So maybe we will not have only one jar file. There could be multiple jar files. Let's say f2.jar, f3.jar, n number of jar files will be there. So not just as one jar file you will get all that code. Maybe they did some more modularity. They wrote more projects and they need all those projects, all those jars. So please be aware, there might be more than one jars, and you have to take all of them and then move it into your project, and then you will get that capability. Please be aware of even this. These are simple basics. I'm teaching you the ABCDs of application development. And now we will be coding it, so everything will start making sense. But for now, you should understand, somebody in the real world has already done the coding, and their code will be as multiple jar files. You can simply take all those jars, put it into your project, and your project will get special behavior. For us, the special behavior is it will become a web system which can be accessed across the web. This service can call that service. Okay. Now, another topic that we said is for the Java related community. Okay, popular framework is Spring and Spring Boot. Okay, and on this website, this is the official website. Yesterday also we launched it. This is the official website, spring.io. And Java is the popular framework for the Java. Spring Boot is the popular framework for Java related community. They have put in very nice documentation about the power of Spring. What more can be done? Okay, and using Spring, you can build, observe so many types of applications. Now you can imagine, Spring the guys did what? So think about it with a very common sense, guys. Okay, let's say you are a developer of the Spring. Forget about what Spring has done. Imagine you are the developer who is building Spring's framework. Okay, what you will do is you will understand the entire world. What kind of projects happen in this entire world, right? Think about it. There are lakhs of companies, lakhs of employees working across the globe in different countries. You will start thinking framework people are nothing but central people which are building some systems which will be used by the entire world. So you can close your eyes and visualize my words. Just imagine in front of you is the entire world. So many companies, so many employees, so many projects. And now you're thinking, okay, what kind of projects can be there? And then you realize some people are doing standalone applications, some are doing web applications, some are doing monolith application, some are doing microservice application, some are doing maybe eventing related applications, some are doing reactive programming style. Different types of applications exist in the world. As a framework, now you have to see, okay, how I can help each of these kind of projects. And you start developing all that code at your side so that whenever anybody wants to develop any kind of project, they can come to Spring and they can use what you have built for them. Okay, guys, think about it. That's the scope of framework. All the types of projects of the world, at least that's the power of Spring framework. Spring has done this work to do it for all kind of frameworks. There are other frameworks in the market like Hibernate and others. They focus on one particular area, but Spring is something which is called as an enterprise level framework. Okay, Spring is called as enterprise level framework. Basic is whatever enterprise applications you want to develop, Spring is providing you a way for doing that. Means once you learn Spring, basically you can work on any type of project. You just need to use the right jars given by Spring and you can do that. And that is powerful if you really understand. So Spring is the enterprise level framework which gives you a mechanism to build any kind of application. We took one example. Okay, we want to build a microservice based application where via APIs communication will be, but using Spring, you can build GenAI related applications, microservice related applications, reactive style of programming, cloud-based applications, regular web applications, front end, back end together. Spring MVC is offering that. Serverless application, event-driven, batch kind of applications. So please be aware, these are the popular types of applications which can be built in across IT industry. It depends which kind of project you are in, right? So depending upon your project, you need to use Spring accordingly. Okay, so that is the first thing you have to understand. Spring is an enterprise level framework. It provides support for building any kind of real world application. And that is the reason Spring is so popular. It's not just like any other framework. Using Spring, you can do any kind of project of the IT world. And Spring is trying to really be in pace. For example, Gen AI and other things, as the field of AI is evolving, they're giving more and more support to these kind of projects also. So first thing you need to understand, Spring is a powerful framework. It's an enterprise level framework. Means using it, you can build any kind of application in real world. These are some of the types of applications. Okay. Second thing you need to understand about Spring, what is that? Okay, all framework code is already done and they are still modifying it. Enhancement is going on. So all the framework code is already done. How have they done it? Is they created Spring team created multiple projects in which corresponding code is available. So where is this available? If you go here into the project section, overview, you can see here all the projects. Because just go back to the same place. Okay, framework code, we took one example, okay, web, but Spring can be used for many things. So what those many things are, they have arranged all the code in multiple projects and you can access that here. Spring Boot is one of the project which is created by the Spring team. So how this happened? Earlier, Spring started with the core Spring framework. Okay. So in the beginning, when the Spring came, they started gradually. And over a period of past 20 years, Spring has reached to the current place. So it is not new. It is like 20 years onwards is going. I think 2023, somewhere around that. Okay. 2023, like 2003. So in the year 2003, these guys came. They started with the core Spring framework. And over a period of past 20 years, they have added much more logics here. Okay. Any type of applications, yes, there are projects available for all of them. Okay. So Spring Cloud, Spring Data, Spring Security, Spring Session, Spring GraphQL. So if you have a requirement, you have to work with GraphQL, you can use this. Authorization server, you can use this. Monolith, we said, right? Spring Monolith. If you want to work with Monolith application, you can use batch related, Spring AI, REST documentation, Kafka, LDAP. Depending upon what kind of project you are building, they have accordingly grouped their projects. Right? So please, you need to understand Spring is an enterprise level framework. Using Spring, you can build any kind of application. Next, Spring has already done the code. Where is this code organized? In the form of multiple projects. Okay, so Spring has organized the code in the form of multiple projects. Okay, depending upon, think as if you are also a developer of the Spring team. It will start making sense to you. Depending upon what kind of application you are building, you will use the right project of Spring. For example, if you want to build an AI, you will use this project. For batch processing, this one, and so on and so forth. Okay. And now you need to understand one important thing. Why is Spring Boot so popular? Spring Boot came, okay, many years ago. It is not something new also. Spring Boot is also now very much old. It's getting old. Why Spring Boot is so popular? Because Spring Boot main aim is rapid application development. We will get into more details about this framework, not today, later on. Today, I'm just glancing through all the topics. Spring Boot ka primary aim is fast application development. Means it's very smarter, okay, easy to work with, very smarter. And you know why Spring Boot is so popular? Because it is not just a random project of Spring Framework. Using Spring Boot, you can develop all the other type of applications in a fast, rapid manner. That is where Spring Boot is so popular. So Spring Boot is not just an independent project. Using Spring Boot, you will be able to work with all other kind of applications in a rapid manner. That is where Spring Boot is so popular. So many, okay, let's not get into details about internals about Spring Boot. We can discuss that later, but for now, you should just understand Spring is the ultimate powerful framework. In that, multiple projects are coming up. Spring Boot is one of the projects whose primary aim is rapid application development, fast or rapid application development. It provides a lot of features by which we can do rapid application development. But important thing about Spring Boot is using Spring Boot. Okay, you can do rapid application development for any kind of application. What does it mean, any kind of application? It could be for GenAI related application. It could be for microservice related. It could be for reactive. It could be for cloud. It could be for web app. It could be for serverless app. It could be for event driven. So Spring Boot can be used for building all of these other kind of systems in a rapid, fast manner. That is where Spring Boot is commonly used. But it is again one of the project given by the Spring. So don't devalue Spring. Like some people, lack of maturity, they are like, Spring Boot is everything. No, it's not everything. Okay, the core foundation, the framework is Spring. And now the Spring team is thinking, how do we make it better and better for the entire world? And they have come up with an initiative of Spring Boot for rapid application development so that all other kind of projects can be done very easily. So understand what is what, you will be able to make better decisions. Okay, fine. Now let's understand this point. Some time ago we said all this code is already available somewhere. Now we need to understand another point. Spring framework is open source. Open source means anybody can use it. It's not commercial, it's not charged. Anybody can use it, and source code is also visible. Anyone can use it, and project source code is also available. What does it mean, project source code is available? It means whatever this code which is available, we said we should not write the code. Spring Framework should do that. So Spring Framework has done this, and they have made the code available in GitHub. So GitHub is nothing but kind of code management. The code is going to be available in GitHub kind of system. It's a version control system. Okay, GitHub is going to use Git. Let's not get into all that right now. Let's not get into all that. But for now, just be aware of this. The code of Spring Framework is available in GitHub. And you can see that. You can see all of that. For example, let's say you are getting into these projects. Initially, it started with Spring Framework. Just observe this. Okay. What kind of features are possible by Spring Framework? They have made details about that here. What kind of applications you can do with Spring Framework? Next, what kind of applications can you do using Spring Boot framework? What is the power of Spring Boot framework? The major features, they covered it here. So I'm just opening the project. They have written very nice documentation. So everybody, every developer can understand it. They have given a lot of examples about it. Okay, fine. Out of this thing, just observe. They have done this one thing also. For example, if I'm going to Spring Boot, they have given project release notes. If you click on this project release notes, just observe. We go to GitHub URL of Spring Boot project. So the code of Spring Boot is available in GitHub. How do you see that? Okay, just click on this code section. And you can find all that code is going to be available here. They have done all the coding here. Okay, where is the code available? They have arranged it in the form of some modules. Just see, this is the entire code. All the code, they have grouped it here. Let's say if you want to work with Spring Boot ActiveMQ. Okay, now SRC, main, right? This is how you do project, package, and then let's say auto configure, and just see This is the code. So the point is, if you want to work with Spring Boot ActiveMQ, they have already done the coding for you. The way Kafka is there, some of you might have heard about Kafka. ActiveMQ is also for that reason, something else. Okay, asynchronous communication. So if you want to work with ActiveMQ, you need some common logic, reusable logic. So you don't want to waste your time. You want to develop only project. So all these common things, Spring is doing it for us. In GitHub, you are able to see that all that code is available. And this code can be taken in the form of jar file. You can add this jar into your project and you will get amazing capability. That is how things are organized. So what I will do, rather than getting into this much of internals, or at least let me put this link in our notes so you can launch it. But please be aware, all the code is available. Everybody in the world can see it. And there are people who are there are people who are coding it on a daily basis. For example, you can imagine, these many number of people are contributors across the globe. 1181 contributors are putting changes into this framework. Observe, 2 weeks ago, somebody made some modification. If you go to this module section, just see, in ActiveMQ, some changes happened 5 days ago. In this one, last month, some change happened. Many places 5 days ago, they are doing modification. Here, 20 hours ago, some LDAP related changes were done. So what is happening? People 18 hours ago, 2 months ago, 3 weeks ago, constantly this code is being modified to make it better and better for the entire world. So I think you're imagining the vastness of the framework. The world, some smart people came together and said, can we build a system which can be used by the entire world? And whatever is the pain of all the projects, let's remove that. We will do it. We will test it and everybody can use it. And they have posted it here. We can see that, we can understand from that. And we will take this as jar file, put it into our project, and then continue building application. Right? So guys, are you getting this? Now we want to build our application. Okay. After looking at this, can you put one-liner comment of, are you able to capture the vastness of what Spring is doing for the entire world? Okay. Put a one-liner comment here in the chat, guys. You need to have tremendous amount of respect for Spring people. What have they done? They are taking the Java community forward, right? Yeah, getting it? Super. Even if you're a beginner, you don't know anything about framework, the past 30 minutes discussion that we did, it should open up your eyes. Ke acha, dunya mein all this happens. And simple example, your method, you want to make it back. Okay, and that is how it is going to be interesting. Your method which you have written, you want the world to access that method. We don't want to write all that dummy code, reusable code. Framework should take care of all that. And then this amazing world of framework is coming in. And it is complex because different type of applications can be there. So you need to accordingly do that. Okay, super. Chalo. Good stuff, everybody. Now comes the point, we need to build our first Spring Boot application. How we can do that? Okay, good. Chalo, let's go forward, everybody. Thank you for your confirmations. Great to see. It's 1.5 hours and you guys are strongly focused. Okay, you guys are strongly focused. There are much more things to talk about frameworks, but not as part of today. We will do that discussion later. Okay, different types of frameworks are there and how Spring is offering. We can do those discussions later. Today, the aim was to make us realize, okay, where microservice comes in picture, where the framework comes in picture. And now we will build our first microservice. That is the next step. Okay, good stuff, everyone. Thanks for confirming. Let's go back into the code. Let's go back into the code. Okay, so our next aim is, we want to code first Spring Boot application. And whatever we have done discussion so far, we need to make it practical. Okay, guys, new things will keep coming. In fact, lot of new things will keep coming. I'm already informing you, but don't be afraid of that. You are here to learn new things. So new topics will come every maybe 5-10 minutes, a new concept. No problem. Open up your mind. I want to show you how the IT industry is operating. And then you have to accept all those things by opening the mind. Even if you don't capture everything in the first attempt, no problem. That is where I give you the recording. You need to repeat the recording again and again and again till the time you understand that concept fully. Okay? So a lot of new things will come. Some of you might already know it. For some people, it might be very basic. But we took the poll in the morning. Roughly 50% people have worked with Spring Boot. Remaining 50 has not worked with it. So I want to really accommodate both the category of people. So we will get into a lot of new concepts. Even if you know it, just revise it once more. If you are not aware and you are feeling, whoa, so many things, no problem. Once you repeat the entire session, do it practically, you will gain the confidence. So we are going to work with multiple tools now. Let me put down the names. We will be using multiple tools right now itself. First, Java 17. So you need to install Java 17 from official Oracle website. Okay, get the Java 17 from official Oracle website. Set it up in your machine in path variable. In your core Java, you will know how to do the Java path settings and all. If you're not aware of that, you should go to the internet, do that. Basically, the aim is, if you do this in your command prompt, Java space hyphen version, you should be able to recognize your Java version which is installed. So Java 17 is already installed in my machine. If you do this kind of statement, you should be able to identify that. So that is the first requirement. Everybody should do that. Okay. Next, for doing the coding, industry works with IDE. Multiple IDEs are there. Which IDE you want to use, it is your choice. I'm going to work with Eclipse STS. Spring Tool, okay, Suite. I think, yeah, Spring Tool Suite. So if you go to this website, spring.io/tools, okay, spring.io/tools. Here they have given this IDE. So Spring Tools for Eclipse. So I'm going to use this one. It's completely your choice. You can use Spring STS for Visual Studio Code if you are interested, or you can go ahead with some other code also, or IntelliJ you can use. Multiple IDEs are there in the market. For demonstration, I will be using this one. So you can get it from this place. Unzip it and it will be available. Okay. So some Eclipse STS, you can find it on this place. Always coding happens in IDE only. Choice of IDE is your choice. In companies, the company guys will give freedom to the developer to choose their own IDE, and accordingly you can set up and continue. Now AI-driven IDEs are also coming, right? Cursor AI and other things. So you can use that variation also in some of the projects. Fine, but multiple options. So we will need Java 17. We will need this one. Next, for getting these jars, for compiling your project, for executing your project, for all these activities, there is something called as build tool in the market. And for the Java related, Maven is a common build tool. We will be using Maven. Today we need to work with all this. So you will have Java 17 installed. You will install IDE. Your IDE will be in your local machine. For working with jars, okay, for working with jars, for compiling and for executing, build and execute process, that we say build and execute process, we will use option build tool called as Maven right today. Next, for doing some testing, we need to use tool like Postman. So right today we are going to use some tool like Postman also. Okay, so at least this basic stuff we need to be aware of. Okay, fine. Already I have installed this. I have this. So generally what will happen? If you are installing this IDE, along with that, Maven support is going to be available. So you don't have to install Maven separately. Okay. Postman, yes, you need to install. So you have to install. Just go to internet and say download Postman for Windows. You will get it. So Postman, you download, or let's say multiple tools. What you have to do, setup these three: 1, 2, and 3. These three you have to do. This will be inbuilt. We will use inbuilt itself. No need of download. No need of external setup. It can be done, but it is optional. Okay, some people set up externally, use it, but not required. Along with IDE, you will get it. But these three things you have to set up today. Okay, fine. For doing the setup, wherever you're stuck, use internet, use ChatGPT to solve your problems. Okay, fine. If you are saying, I want to use a different version of Java, can I use it? Yes, you can use it. But whatever libraries we will write, we will make it compatible with Java 17. So if you are using a different version and if there is a compatibility problem, so you have to then explore on internet and resolve that. Okay. So, but during the session, my code, which I will be sharing with you, whatever we code on a weekly basis, I will share it over to you on weekend. That code is going to be all set up for Java 17 versioning and everything. So that's what it is. So you can choose the latest one, just that make it work properly by exploring on internet for right versions. Okay, fine. So this much is done. Now, go. For getting started to build first Spring Boot application, the Spring team has given some nice tool called as Spring Initializr, which is nothing but start.spring.io. Okay, so this is one of the way. You can do it from your IDE also, but this is also one of the way. You can simply go to start.spring.io. You can fill up a few things and click on generate. Your first sample project code will be ready. Okay, and then on top of this code, you can do other coding. So this is how you can get started. So for building your first Spring Boot application, there is a page which these guys have offered called as start.spring.io. Okay, here you do some basic selections and then you can create your first application. Okay, now let's understand. You can build a Spring Boot application using even other programming languages like Kotlin and Groovy. Okay, so I think this is really interesting stuff. Let me go to ChatGPT. Okay, what is common between Java, Kotlin, and Groovy? All three are JVM languages. Means in order to run a Java application or Kotlin application or Groovy application, okay, they can all run on JVM. All compiled to Java bytecode and run on Java virtual machine. So please be aware of that. So this support which they have provided for these three languages is because every time you build this, you get bytecode, right? .class file. So with this also, you will be getting the bytecode and you can take this and you can execute it in a JVM. So nothing but Spring Boot kind of support is available even for these because they are also operating on the JVM itself. Please be aware of it. Next, which build tool you want to use? We said build tool is required for jar management, for compilation, for executing your application. We will be working with Maven. So always in the companies, you will need a build tool. Without that, nobody will manually maintain all the jars. I said, right, we need to get these jars, put it into class path. Nobody does it manually. We need a build tool for that. And Maven is going to be there for that purpose. For many projects, Maven will be there. Some other tools are also available, like Groovy is there. So you can check the name. So some other tools are there, but Maven is very common and very much utilized in the industry. So let's start clicking the checkboxes to get our first project. Okay. So we need to build Spring Boot application in Just see Spring Boot application in Java. Our build tool is going to be Maven. Latest stable version of Spring Boot is 3.5.6. All the things which are having bracket means they are still under some testing, enhancement, some kind of phases. It's not fully ready for the world. The one which is not having any parenthesis, that is the latest stable version. So currently it is 3.5.6. If you go to Spring Boot documentation, let's say learn, just observe. It is maintaining that, okay, currently 3.5.6 is the current and the latest version. This much of work is going on right now. People are working on 3.5.7, then 4 also is being worked upon. And as and when these releases come, new and new softwares will come. And as part of every release, what these guys are making changes, they will keep informing it in these reference docs, and there are API docs and all available. So please be aware, people are constantly upgrading the framework. The latest versions are there. So please note this. Spring framework is also one of the project. So it will have its own version cycle. So sometimes junior get this kind of confusion. What is this Spring version is different, Spring Boot is different, because they are two separate projects. Spring framework is a separate project. Whenever they make any change, they track it via version. And Spring framework has come before even Spring. So their versions are right now lying in 6.2.11 is the Spring framework version. However, later Spring Boot has come into market and the current stable version is 3.5.6, 3.5.6, and you can find it here in latest stable version also. Okay, fine. Next, for every project that you create, some basic information we have to fill. We will understand that. Okay, some basic information is required. What is it? We will understand that. But meanwhile, let's continue further. In order to execute your application, there is a strong recommendation almost across the industry. We use jar file version, and var file version is not being utilized. Nothing but when you are building the project, we took this example, right? Spring framework guys have also built the project. After they have built the project, we want to use it. How is it possible? Oh, they give the jar file, we take the jar file. So like that, we are also going to build the project. After that, if you want to execute it, okay, you will be building a jar file. So there are two ways. Either you can do jar or you can do var. But the recommended practice is jar. Many projects in IT is using jar approach. Almost more than 90% projects using this approach. For executing your project, you will need a jar. Right now, you will not understand it. When I give an example how to use this jar, then it will make sense to you. In the coming few days, we will be talking, especially when we discuss about AWS. Tomorrow, when we talk about AWS, then you will know the need why jar file based approach we are following. Okay. For now, just be aware the way their project code is made available as jar file. When we complete our project, we need to decide what should be our final output. Should it be a jar or should it be a var? So we want it as a jar file. So that is where from start.spring.io, we will choose Java, Maven, latest stable version. You will come here, you will choose a jar file. And what Java version we want to use? Java 17 we want to use. Okay, that details are done. Okay, next, what is our aim here? We need to create Spring Boot application, which is nothing but a web project, so that we can write our REST APIs. Know that this is our project requirement. This is our project requirement. We will expose REST APIs to other people, right? So we need to make a web project so that other guys can call us. So our requirement is something like this. We need to build some REST APIs so that merchant system can call us, which is nothing but web project. Okay, Spring has given an easy way. Okay, you want this to become a web project? Okay, fine. here you just choose web. Okay, we said, right, all the Spring code is available into this repositories. How to get the right project code to you? That is managed by these dependencies. So when we choose the right dependency, let's say web, just read the description. It will be used for building a web application. You can build RESTful applications. There is another style like Spring MVC applications. We will discuss it later, not required right now. So basically, if you choose web, you can build web applications. Okay, let's say you want to implement AI, you can do AI. Let's say you want to implement OpenAI. You want to use the libraries which are given by OpenAI. Okay, some code for that is also available in the Spring ecosystem. We said, right, in this project, they have created something called as a Spring AI also. So that kind of code can be extracted by adding the right dependency. Some time ago, we said, right, using Spring, it's an enterprise application. You can build any kind of project. So they have done that much of coding. But how do we add this code into our project? By choosing dependencies. So depending upon what kind of project you want, you will add those dependencies in your application. Currently, we just want to build a web project. So we will add only Spring Web dependency. Okay, let's draw some conclusions about what have we seen here so far. Okay, let's go back here. We can get started to build this project from this place. Okay, we will be doing it for Java, Maven. Okay, we got understanding that Spring Boot offers support for even Kotlin and Groovy language. They are also JVM based language. Okay, next we are using Java, we are using Maven, we are using the latest stable version for our first application. Okay, next, this some metadata is there. For every project we need this information. What is this information? We will discuss it in some time. But next, we need jar file. When the project is ready, how do you want to really have the final output as a jar or var file? Tomorrow when we discuss AWS, it will become clear. So we have chosen final output or final build file to be .jar file in nature. Okay, next, Java version 17, Java 17 we are using. Next, choosing dependencies, we can add whatever capabilities into this Spring Boot application. So choosing right dependencies, we can add whichever capability to our Spring Boot application. Okay, for example, I just clicked here, search for web. For making web, we just need to choose Spring Web. Okay, for example, choose Spring Web for making a web application, including REST API. Okay, fine. Chalo, choose unselected. Now, you can add more than one also. Let's say currently web is already there. You can add another dependency. Let's say OpenAI, if you want to work with OpenAI related library. Okay, done. You want to work with something else, JPA, you can add that also. N number of dependencies you can add, and then your project will be capable to use that reusable code of the framework. Okay, fine. Now, let me remove this OpenAI. We don't need it. They provide a lot of features, inbuilt features, guys. Frameworks are powerful. Okay, so we added only Spring Web. Okay, fine. Now, let's understand this section. Okay, few things we need to be aware. What is group? the technical company which is developing this project, their details will be specified by group. Okay, so group, the tech company which is developing the software, their name is going to be specified. Okay, so let's say there is a company Google, right? So what is the Google domain? Google.com. So whatever is the domain name, reverse of that becomes the group. So it will become com.google. So this becomes group. This is the domain. So for example, if you have your own company, let's say mycompany.com. So your group will be com.mycompany. So what exactly? This domain is unique for you. So if you reverse it, so this group can uniquely identify which technical company has developed the software. Okay. Sometimes the clients will be there, right? They will say, use our company name rather than your company name, use our company name. It depends. Sometimes clients might say like that, and accordingly, the technical team will decide. But basically, group identifies which company has built that software. So reverse of the domain. So what we can say, com.mycomp. Fine. Next. Okay. When your project is built, the way here we are saying, when this project is built, finally jar file should be created. Okay, what should be the name of the jar file? That is nothing but artifactory. Artifactory. Okay, what should be the name of your jar file? So let's say we want it to be, let's say, first app. So that is artifactory. When your project is built, artifact. When your project is built, okay, what name to use? That is nothing but artifact. So it is going to be somewhere like first name.jar. Next, what do you want to be the name of your project? So we can choose it like this. You can choose the description about this. Okay, and then this is something called as a base package. Nothing but all the Java code that you will write in your project will be under this package. Generally for packaging, you will use everything small letters, and generally you avoid even this hyphens or underscore. You can simply say first app. So some package naming conventions are there. Don't use any capital cases. Don't add hyphen, underscore, and all that. Keep it all small, dot separated, and that's it. So this becomes the base package. Okay. So this becomes base package. Package name. Like this. This becomes base package. Means all your Java code will be available under this base package. So let's say controller layer you want to develop. You will choose something like this. com.mycom.this.controller. Otherwise, you will continue with the other activities. Dot service, if you want to do, you will do it something like dot service and dot repository or DAO, and like this you continue. Okay, very good. So these are all the details with to start.spring.io. Very basic. Every developer should guaranteed know it. You can do this via your IDE directly. A number of ways are there. I'm showing you one of the way. Get started from this place. After choosing all this, we just need to create generate. It will create the first project with this dependency and is available in this zip file. Okay, so let's open this. Let's open this. So it has properly read. Because of this web dependency, internally it used Maven, and it found for this web dependency what all jar files I need to get from all this code, and it has taken all that jar file and is available already inside this zip. That kind of combinations. It's not like actually jar file is available here. Some Maven configuration for that jar file will be there. just imagine if so many jar files are added in the zip, the file size will become too high, right? But theoretically, this zip knows what jars we need. You can imagine that one. So based upon the configurations which we have done here, our first application is ready. Okay, fine. So that is the step number one. What is the step number one? Go to spring.io, build your first Spring Boot project. Step number one. Okay, step number two, launch your IDE. And this is an existing project. So there is an option in IDE called as, okay, import this zip into your IDE. And after that, we will continue with the next steps. Okay. So guys, when you are launching the IDE, it looks something like this. This is STS, this is Cursor AI, this is Visual Studio Code. Depending upon your preference, you can choose whichever you are comfortable with. So we are going to work with Spring STS. So let's click Spring STS. Okay. Now, generally, you have to understand one point. Keep your local folder organized. Every developer should do this, because once we get into Git branching and other things, if your local folder structure is not proper, it is going to get into problems. So what does this mean? The way package is having something like base package, right? So this is going to be base folder location for our project. Means when you are working, everything you will put as part of this. So whenever you start a new project, this will become your project name. Let's say in your company, you're going for different projects, and whatever you might have, for every project, you generally create a new name. So payment integration, you are working. Tomorrow, let's say you start working on e-commerce. So that project separate, this project separate, have a base folder path. Okay. Now, under this, all further subfolders will be there. For example, when you're launching an IDE, it needs to generate some temporary files behind the screen. You can put that as part of /IDE folder. So creating this kind of a folder, okay, IDE can generate some temp files or some plugins and all. So let that folder be there. So you don't touch it. Let the IDE do whatever it wants to do with it. So you can simply choose the base path /IDE. Okay. So since we are doing the October 25, we have been doing many month by month batches. Okay. So for example, so I just use this naming for being organized, nothing more than that. Okay. So before October, we completed the trainee program for August. Before that, every 2 months, we start one batch. So then June, April, Feb, November, September, July, May, and this is happening since long time. Okay, this is happening since long time. From 2023 onwards, it's going on. And right now we are in October. So I just uniquely identify it based upon naming. So this is October 25, and CT stands for Career Transformation. That's the alias for the program. Okay, fine. Now, under this IDE, all the temporary files will be generated. Now here we go, and just click on launch. Give it some time. Okay. It will take some time. It is doing the startup. Here it is doing some initialization. Let it run some activities. Okay. So please note that in my IDE, I have already added Copilot or Eclipse. This is nothing but GitHub Copilot, AI pair programming support. This is optional. You can go to ChatGPT, get the code from there, and then put it. That is fine. So, but yes, I am having GitHub Copilot support using Copilot for Eclipse. Okay, so just be aware. So it is going to recommend me a lot of code when I am doing the live coding. Okay, so my IDE. So I think for students, GitHub Copilot guys are giving some direct access free versions also. So just like your university, I think some naming should be registered somewhere. There is a process for students. You can explore that and you can get it. But yes, my ID is having some support for GitHub Copilot. This is for AI pair programming, or people are also using this term vibe coding. Okay, and the plugin for that is Copilot for Eclipse. Okay, Copilot for Eclipse. You can search this and you can add it. Your process will be, first you need to go to GitHub Copilot, create an account there. Okay, yes, I think monthly it is paid, but as a student you can check whether free version can be taken advantage of. And then once that account is created, then you need to set that up in your ID. When you are setting this up, you have to link it with your GitHub Copilot. On YouTube you can find all the ways how to do all these things and get it done if you want to use AI capability. If you don't want to get into all this, ChatGPT open free version is available. Just go to browser, work with ChatGPT. It will suggest you code. You can put it into your application as well. So please be aware of that. Okay, fine. Empty folder space and empty workspace is ready. Okay. Now, what are we going to do? Just observe. These are some straightforward things. In the download, we have this. Next, we have installed this CD CT workspace / October 25 CT. This is the base folder location. What I'm doing is, since today we are doing some exploration, here I'm creating a new folder called as Explore. Under this Explore folder, I'm just taking this first app.zip. This zip file, we got it from the start.spring.io, where we have chosen that we want to build a web application. It is available here. Okay, fine. Next, we are unzipping this. Okay, right click, extract all. Let's say on this folder, just observe these are basic operations, nothing to explain here. Just observe folder creation, copying, pasting, nothing more. Once you open this first app, okay, some nesting has happened. So this is the code which was generated. So I will just cut it, move one level up to put it in that folder, and we will delete this internal folder because nesting happened. So we have just removed it. So basically, whatever zip code came from start.spring.io, we unzipped it. That's it. Okay, by having an organized folder structure. So let me just write down that. Okay. Keep your local folder organized. Next, under Explore folder, we are putting Explore. Unzip the project which you got from start.spring.io. Okay, fine. Next, there you guys. This is the first project. Once we put this project, on this project, we have to do a lot of coding. So even though if you are first timer for this or you already know this, but yes, this is the basic. We need to have first project running. Then on top of that, we can do a lot of other discussions. For example, tomorrow when we connect, we need to understand, okay, the concept of profiles, and we need to work with environments, and that is where we will go ahead with AWS. So we cannot do that if this first project is not ready. So today you need to do that. Okay. And yeah, chalo, let's focus on this one by one. So for some of you guys, it might be very basic. For some, it might be first time, so many things happening. No problem. Observe, understand. Okay, because this is very basic, needed for every day in companies. Next, so we extract this. We got this project. Fine, that is what is written here. Okay, unzip and it's available here. Your next step is import this unzipped project into IDE. How to do that? Okay, straightforward option is available here. Import project option is available. So click on import project. Search here for Maven. You can type here Maven. You will get this option. Click on existing Maven project. Okay, so here if you search for Maven and then click on existing Maven project. Why existing? Because that project is already existing. From start.spring.io, it's already there. Okay, so from here we are importing. So we will copy this URL. We will copy this URL. Go here, say existing Maven project. Observe the steps closely here. Next, you put up this location, give an enter. Important thing to notice, lot of new things will come. All Maven configurations, Maven is for jar management and other things, are available in pom.xml file. What is Maven? Maven is a build tool. Build tool. Why do we need it? For jar and dependency management, for build activity, for execution. Okay, where are the Maven configurations? Pom.xml contains Maven configurations. Okay, very good. So as soon as we add this, click and enter. Okay, IDE is smart enough and it's looking under this location. Is there a pom.xml? Okay, yes. Next, whatever is the name of the project, make this as a habit. Whatever is the name of the project folder, you click on advanced and choose the same for the name template also. Make this as a habit, regular basis, to avoid any confusion. Okay, whatever is your name of your folder which you use, keep the same as the name template. Make it a regular discipline. It will save a lot of your time when you are working on more complicated many projects together. Okay, fine. Next, do a pinch. Give it some time. Give it some time. It is reading it. Meanwhile, by the time it is reading, let's observe here what has happened. This is a kind of a folder structure which came. SRC main Java. All your Java code is going to be here. Your package is like this. com.mycom.first app. Your package is here. Any other files if you have, like property files, HTML files, log files, it will be available under resources. So all your Java code when you write in project will be here. Under resources, any other kind of file will go under resources, like property files and all that. And SRC test Java is going to have your unit testing, integration testing related classes, and remaining is just the setup. Okay, so when you are doing the project, if you have Java code, you will write under SRC main Java. Test classes will go in SRC test Java. Any other files like property files or log related files or any HTML file if you have, images if you want to put, they all will go under SRC main resources. Okay, and at the root level, pom.xml is there, which controls the Maven configuration. This much basic you need to just understand. Okay, and already observe these three things mentioned here. It is very small in size. Okay, but even though if it is small, it is giving us some clarity here. Just looking at this, we can understand M is for, it's a Maven project, it is a Java project, and this is a Spring Boot application. So the IDE has read all that and using some symbols. Spring Boot, this is a Java application, and this is with Maven build tool, Maven support. Okay, fine, that is what is available. Okay, now So currently, whatever code this guy has given, even in your core Java, you know, the starting is a main method. So your Spring Boot application is going to start because of this line. Whenever you want to run this project, you need to just run this main method. And then this line is going to start your Spring Boot application. And there are certain annotations. What is all these annotations and other things? Not required right now. Some other day we will discuss. Okay. But yes, this class which you're passing here should be annotated with Spring Boot application. So for now, just be aware. The starting point of your project is this. The starting point of your project is this class. First app application is the starting point. Okay, fine. Some basic property files, if you want to put in, you can put in here. So every project will have certain property configurations. Property is nothing but key value configurations. Okay, this is key equal to value. Key value configurations will go in property file. You can write YAML also. Sometimes YAML file will be there. If you right click here, there is some support, Spring convert property to YAML file. So please note, some of the projects will not have .properties file. They might have .YAML file. Basically, it's for configuration only. Syntax is different. Anything is fine, whichever you guys are comfortable, that team will be using for the system. Okay. So multiple things we are noticing here. What is that? What is that? Okay. Under SRC main Java, your Java code will be going, and you will write your test code under here. When you do coding, unit testing and integration testing code will be going here. Under SRC main resources, all your other files like properties, YAML, log related XML files, images, HTMLs, if you have that. Currently, we don't have any front-end related activity, so these two things will not apply. But if any such things are available, it will go under resources folder. We are going it very basic, so there is 100% clarity for everyone. Nothing surprises you. And next, for your project, pom.xml is the Maven configuration file, pom.xml. Okay. Now, whenever you write any code, let's say even core Java application, automatically our aim is to execute it. What do? You compile and then you run, right? So what is that? Java C and then Java. Using these kind of commands, you work. We are building a web application. How do you do this kind of compiling and execution activity? Okay, use Maven commands. Okay, using Maven commands, we can compile, we can build and execute this application. Okay, so understand what we are saying. We are just trying to explore the package structure, how the folders are arranged. Now we are discussing how do you execute an application. We have not written any code, but start.spring.io gave us something. Maven support is there. Can we try to execute what we have right now? Then we will add code to that. How do you compile and execute this application? We have support of Maven build tool. So some basic Maven commands we need to be aware of. Okay, what is that basic Maven command? MVN clean. Clean is kind of refresh. Some temporary files, if there are there, it will be deleted. MVN clean will delete some temporary files. Next, MVN package. If you do this MVN package, it is going to first compile the code. Next, it will run test cases. If there is unit testing, it will run test cases, and then it will prepare final jar file or var file, depending upon what did you choose in start.spring.io. Accordingly, it is going to take the shape. So when you do mvn package command, it will first compile all your Java code. If there are unit testing, it will run those cases. And finally, it will prepare the jar file. That is Maven package command. Okay, let's try to run these two commands and see what happens. Okay, now another point. When you are running this from IDE, when running Maven commands from IDE, you don't have to use the mvn keyword. mvn is not required. Approach is going to be different. Okay, how do you run it from your IDE? Approach is going to be different. Something like this. Observe, right click, run as. Anyways, the recording is going to be available for you, so you will not miss out any point. Watch it again. Basically, for first timers, yeah, you have to be careful. We will do this hundreds of times as we are going forward every single day. So right click, run as. Just click on this Maven build with 3 dots. Okay, Maven build with 3 dots. There are shortcuts available, but I'm telling you a generic way which you can use for anything. So Maven build with 3 dots. It is going to show something like this. In goal section, you need to use these commands. And when you are using it, don't use mvn command there. So in goal, you just write clean. Clean will basically delete some previous files. That's it. So you now click on run. Maven will be installed with you when you are installing the IDE itself. So you don't need any special setting for that. Okay. It is trying to do certain activities. We simply asked it to do a clean activity. Okay, what is a clean activity? Notice when you're doing a clean, it is deleting some internal folder. Content of target is being deleted. Just observe. When your project is available, there is a target folder. That means whenever you're trying to compile, it will prepare some jar file and other things. It will do it under target folder. So when you do clean, basically it just deletes the target folder. So previous code and other things are not there. That's the power of clean. So what is clean? It will delete the target folder. What is there in the target folder? All jar files which are prepared or any other kind of outcome files, jar files, other files which are prepared while build happened is going to be there. So it will delete that kind of folder. Okay, now you want to do Maven package. So the way regular core Java application, you do Java C. But for this application, when you do Maven package, it will do 3 things together. Compile it, run the test cases, and have the final jar file version. Okay, fine. Let's go forward. So we will go same process. Right click, run as, Maven 3 dots, Maven build 3 dots. Goal, this time we don't use mvn. Please be aware. If you use mvn, it is going to fail. So now we will do package. That's it. Package and then run. Give it a few seconds. Okay. Just see, in between it tried to do some compilation. Internally, some of the libraries are using some versions which Java is saying, okay, we might be disabling it in future versions, maybe in Java 25 and all. So they keep putting these kind of versions. So internally, some jars of Spring Boot are using certain features of Java, which looks like will be removed in future. So some kind of warnings are coming with that. Anyways, when you are upgrading to different versions, there corresponding Spring Boot versions will be there so that these kind of warnings will go away. Okay. Next, what did happen here? Observe, compile. So currently we have only one Java file. So compiling one Java file. Next, what happened? Test cases. Observe, we did not write it, but in the beginning itself, the start.spring.io has written one basic test case for us. So this @Spring Boot test is trying to do some testing. Right now, don't get into what it is trying to do, but it is trying to run some testing. And yes, so test cases are running. And it tried to do certain activity. And once ran test case 1, okay, it was not a failure, it was not error. So it ran test case 1 successfully. Finally, it is trying to build a jar file. Because in start.spring.io, we said jar file should be prepared. And this is the name of the jar file which it prepared. In the artifact location, just observe here, we choose jar file. We choose artifact name to be first-app. Because of that, this beginning part is first-app. Remaining, it has temporarily added some version to it. Okay, more discussions about this. We will be doing it later as we are progressing with building our application. But yes, whatever we wrote in the artifact name, it is coming here. And yes, the jar file is prepared. Where is this jar file? Under target folder itself. Okay. Again, basics of Maven. This much of Maven is essential for getting started. So what is our process here? We want to do run Maven commands from IDE. You don't need this. So what is our process? Right click, run as, right click, run as, and then Maven build ... And then in the goal section, you can use clean, and otherwise we have used package. Now, you have to understand this thing. You can use both these commands together, and that is a regular practice for the projects. So you should always do goal and then mix these two commands together. Put it clean space package. Always do it like this itself. Never do it separately. Just do it always in like this. So it will first delete the previous file and then it will continue with new jar preparation. Make this as a regular habit. So we will be continuing with this approach. Right click, run as, Maven build. Today, all this setup should be there for everybody, because without this, tomorrow profile coding you cannot complete. Profile needs the first application to be ready. So you cannot complete profile based upon this. Tomorrow we will discuss how to run it in AWS. And you don't have to set up an AWS account. I will give you a way of how to do the same in local machine. For that also, this first project is required. So today you have to complete this first activity. Whatever we are doing, setup should be ready, application should be ready and working at your side. Okay, so you should run this command, goal, clean, package, and then go. Both of them together, space separated. It will do both the things one by one. Everybody, build is success. First, it tried to delete, clean, and then it is trying to compile and do the stuff there. Compile and then run the test cases, build the jar file, and the jar is prepared here. How do we know that the jar is prepared? Go to our folder. Under target folder, just see the jar is available here under target folder. So fine, under target, it is adding the stuff here. Okay. How it is doing that? We said when you run these Maven commands, it basically reads pom.xml, and from there it is trying to figure out what needs to be done. Okay, let's observe this thing. We are opening pom.xml. It is giving some compilation problem. The reason being, whatever one of the certificate, SSL certificate of Maven is expired, so it is having some problem. So you just remove this and make it HTTP. The way all the other places is talking like that. In start.spring.io, basically those guys should remove it. But if they have not done it, so let's remove it, and then it becomes a successful compilation one. This is how pom.xml looks like. No need to get into very details here. Okay. But key things. We have chosen version 3.5.6. There, we have chosen version 3.5.6. So yes, that configuration is coming here. Next, we have used this group ID and artifact ID, mycomp and artifact ID. So it is coming here. Version, it by default appended. If you just remove this, so in your final jar, this is not going to come. If you just make the version empty, it is not going to add this thing. So it's up to you. Next, name of your application, description of the application. So whatever we filled here is available in this section. Okay. Next, some basically empty tags. We said Java version 17, it is coming here. Okay, next. Now this is interesting. When we added this web dependency, behind the screen in pom.xml, it added this configuration. Okay. Please note that starter is one of the feature of Spring Boot. Spring Boot starter. We will discuss more about that. Ease of dependency management can be done. The jar dependencies, it will become easy for you to manage using the concept of starter. Spring Boot is for rapid application development. Many jars are required. So starter we have launched. So just by adding one value here, your application can get a lot of capability. So for now, just be aware. Starter is one of the features given by Spring Boot for rapid application development. More details about it, we will discuss it later. Today, first one glance about full project we are trying to touch, starting with microservices to building the first one and to where we are right now. A full glance of building an application we are touching today. Okay, so using this simple concept. Okay. Now, you know what? This is interesting. Spring Boot starter web. The Spring Boot team in their GitHub. Okay, this is the GitHub of Spring Boot. Has given configuration, just see starter configuration for web, Spring Boot starter web. So when you are writing something like this, Spring Boot starter web, it is going and reading this kind of configuration. And in this configuration, it is reading, okay, whenever somebody says web, what kind of jars I should look for, it is looking for all those details. And fine, something is there. It is internally using some Jackson. It is internally using some Tomcat, some web MVC. So internally, it is making use of multiple other dependencies. By this way, it finds which kind of projects I should give it to these people. So what is happening is we have configured this kind of dependency, but behind the screen, whenever we use like this, it goes to the starter project of Spring Boot. It reads what all dependencies I need to take, because we said in the beginning itself today that the framework has written a lot of projects. So what all projects I need to take, it will be all mapped under this location. Then one by one, it will read all those projects. For example, if it is coming to Spring Boot MVC, it is going to be a separate configuration here, Spring Boot Web MVC. And if you go there, internally, that will have some kind of changes. It is using so many other things. So indirectly, if just imagine, if as a developer, you need to find all these kind of projects and add it. Just see, test project is added as part of that. Jackson, Tomcat, micrometer, lot of changes are inbuilt coming to you. Okay. So what is basically happening? All this complexity is hidden from the developer. You just have to add this kind of a dependency internally. The projects are dealing with a lot of complexity for you. And what will happen is it will go to the Spring related world and find all of these dependent jar files and make it available to you. So what basically happens, when you use this Maven package, so we said this, right? Compile, run the test case. But what it will do, it will also read pom.xml, check the dependency, okay, import all jar files or download all jar files, into your project class path. This much of work is going to happen. Before it really tries to compile, it will try that, it will read the pom.xml, it will check what dependencies this guy is having. Accordingly, it is going to go to the Spring related system where it will start working with all this, and then all the dependent jars will be taken and they all will be added in your class path. Okay, where can we see that? That's really amazing. If you go here, Maven dependency, just see so many jar files came in your project. And do you think now it's possible to manually select these jar files? No, not going to happen. That is where we need faster system, easy system. And we did not even know this. We went to start.spring.io and added simple Spring Web, and just application is building basically. A web application is building. Without even knowing what is a web application and how it all works, we were able to run it. That's where the industry is. You think fast, you do fast, you're ready with the first application on the second day of this 2 months itself. So this is what is the core things everybody should master. All these terminologies, how these pom.xml works, how it relates to the Bitbucket related code, and how the cross dependencies are managed, and how those jar files are basically added here. Maven and this starter configuration is doing all that hard work for you. Okay, fine. So here we are. Gaadi abhi tak yahan tak aa gayi. Okay, guys, whatever we are discussing so far, could you please mark understanding score here? Okay, please mark your understanding score here. Start a poll. What is your current? Some of you might already know this. I understand, but we have to start with basics because lot of concepts might be there, and some guys at beginner are confused, wrong terminologies also. So we need to start from very basic. And for all the new guys who are seeing this for the first time, it might be a lot of new things, but it is okay. Today is the first day for that, right? So what is your current understanding score? Okay, so let's do that. Let's see 5. And today you have to complete this. Whether you are aware of it or not, one full cycle you have to do it based upon what we are discussing. The more you practice, the more you get better in this, guys. It's that simple. If you keep doing it, you get better. If you don't do it, working people are daily doing this thing only. So if errors are coming, they are solving errors. They are coding daily. They are thinking daily. They are understanding requirements daily. So you have to do that. Then the industry is having a lot of opportunities, lot of jobs. But you have to be really good and then hunt for the job aggressively. When two things happen, then results will come. And guys, don't worry about AI taking away jobs, because even when the times of AI, the industry always needs top 20% of good candidates. So we need to belong there. Market will always take you. For building AI-based systems, also human beings are required. For managing it, human beings are required. But will all the industry required? Maybe not. Maybe bottom 50% will not be required. But top 20, if you belong, you always have a good chance, right? Please be aware. Market might go up and down, but good people will be required for the industry. Think about it from that. IT industry is leading the entire world and all this change. Do you think without human beings, the entire industry will start operating? Or indirectly, the entire world can start operating without a human being? It's not going to be possible. So the bottom 50% might be removed, okay, because of whatever things. But the top layer will always be needed. Smart developers will be needed to build an application, to use the AI. And we have to belong into the top 20% of the world. And that's what should be aim of everybody, right? So be there, work on your dreams, become valuable, become important, gain knowledge. You are smart, apply your smartness, apply your dedication, and become really great. And you will be having a great career then, right? Grow. Fine. Roughly around 260 members have voted so far. and we see around 90% is having strong understanding. That is awesome. You can imagine, right? 90% people just with slight direction are grasping it. Means your brain is really smartly catching up the things. Work towards it, right? Practice it. Once you do hands-on today, hands-on practice today, everything becomes good. Okay, that is going to seal your knowledge today. Fine. And if errors are coming, use ChatGPT, solve your problems. Maybe in live in 3 hours we did. Basically, first half was just conceptual discussion. In 1 hour, 1.5 hours, we completed till this point. So the point is, it might even take you 2 hours or 3 hours. Do that. Do that. Watch the video again. So what should be our approach? Okay. What should be our approach? Once we complete live, your approach should be again start entire YouTube video again, maybe with 1.5 speed or 2x speed. That's where I give the YouTube access so that you can practice it. And while you are watching second time, do the setup, do practically. Okay, if errors are coming, stop that video there. First solve the error, do the research. While this daily you have to do it like this only, while working on task. So if you're watching the video again, you will not forget anything. 2 times repetition plus task is happening. While working on task, if stuck somewhere, explore on AI and internet and solve your problem. Like we said yesterday, nobody's coming to solve your problem. You need to do that. That means you are capable to work in the IT industry. You can deal with your own problems. You can solve it. So use internet, solve it. Once solved, continue video till the end. And on a daily basis, I will share you list of tasks and just submit the task form. It will help you to daily grow. And each and every day, you will realize amazing knowledge is going to happen. And what people become in 1 to 2 years, you will gain that knowledge in 2 months. But serious work is required. Serious work is required, guys. Okay, very good. Chalo, roughly around, you can see 320 plus members have marked attendance, marked this poll, and 90% people have understanding. So you're smart. Practice with dedication. Hunt job aggressively. I will share you techniques of job hunting in later sessions. Do all that work with dedication. Results will come. Okay? Matter of time, matter of dedication. Fine. Chalo, let's go to the final piece. We are in like next 20 minutes about to complete the call. We will continue with the rest. What have we done so far? We build the application. Okay. The jar file is prepared. So this is nothing but compilation. What generally you will do like Java C and you're ready with compilation. That is compilation. Now we want to execute this application. So much of Java code and other things also we realized. Okay. Now we want to execute this application. How do you execute the application? In simple core Java, you know, you need to write a Java command. In this, there are multiple ways to execute. So as we continue with multiple practices, I will keep revealing more and more ways to run it. For now, we will use execute using Maven command itself. For example, Maven spring-boot:run. Follow the syntax properly. A lot of people, they don't put colon properly, they don't put hyphen here properly, and then Maven is failing, and then they're like, what is happening? You have to be careful. These are commands. This is syntax. You change something here, it fails. So be very careful when you do that. So just you can start your Spring Boot application using this kind of a command, spring-boot:run. Okay. And always before this also, you can put a clean word. So this is your command to run your Spring Boot application in a Maven style. There are multiple styles here. You can run it as a Java application also. I'm giving you one of the style. How using Maven command you can start your Spring Boot application. Just run the command like this. Okay. Clean spring-boot:run. It is going to start your Spring Boot application. Okay. Chalo, let's start it. So how to do that? Same process again. What is that? right click, run as, Maven build. Don't use MVN word. MVN is only for outside. If you use MVN, command is going to fail. So use only this whole year clean, and after that spring-boot : run. Just do that and just run it. Let's see how it goes. Few things has happened. Just see. It started some Spring related file. There is some banner settings. From that banner settings, it loaded this kind of text. You can override, you can change it, all that fine. Next, Spring Boot application 3.5. Fine, so it is started. How do you know that it is currently up and running? Okay, two things you have to focus. One is here, this kind of a red symbol should be there, which is nothing but option to terminate. Means if you click on this, your Spring system is going to stop. Currently it is running. If you click on this, let's see, I click on this. Okay, it is gone. Now Spring application is down. Okay, so it should be up with red. Now it is down. Okay, fine. So we have to start it again. Right click, run as, build, clean, spring-boot : run, and then run it. So how do you know whether it is working? Okay, two changes. First, let this continue. Okay, it is done. Two things you have to observe. First, here red mark is there. Option to terminate is there. Okay, very good. Second, in the end, you should see something like this statement. Tomcat started on port, some kind of port 8080, let's say, for example. Okay, now what is this? What is on this? Let's understand one thing. Okay, you are great in the time of Spring Boot. Earlier, you need to, even in your course, maybe 10 years ago, if you are doing a course, you have to spend a lot of time in understanding what is Tomcat. Nowadays, not required. You are using such a big software behind the screen and you don't even need to know it. That's where the world has evolved. You don't need to even do the setup, install Tomcat. Everything is happening internally for you. That's where Spring is for rapid application development. 10 years ago, you had to spend time in learning Tomcats and everything. Now, without knowing it, you can run your Spring Boot applications. So, but yes, some conceptual knowledge we will discuss about Tomcat here. Only conceptual, no need to get any into setups or anything. But please be aware, when you're running your simple core Java application, you compile using Java C, you execute using Java, and JVM comes and runs the game. But when you are building web applications, we have added the dependency, right? Spring Web. When you are building web applications, to run web applications, you need servers. Without servers, web applications cannot be executed. Tomcat is one of the server. Tomcat is one of the server. Please, we need to understand Tomcat is one of the server. It is called as embedded server. Embedded server means it is available to you along with your Spring Boot application itself. You don't have to install it separately and use it. Embedded server, it is coming to you along with Spring Boot app itself. You don't have to externally set up. But few things you have to understand. In order to run a Spring Boot application, you need server. Without server, you cannot do. In the market, multiple types of servers are there. Okay, multiple server softwares are there. Tomcat is one of a popular used one. You can use this even in our production. Many of the projects are using Tomcat server itself. Okay, sometimes people might go for premium servers like paid servers. Tomcat is open source. Anybody can use it. Sometimes premium servers might be there. People might use that, but it completely depends. Many projects in production even use Tomcat also. But you need to understand, for running a web application, we need a server. Many servers are available in market. By default, Spring is giving Tomcat, and Tomcat is commonly used server. It is an embedded server. Means along with Spring Boot itself, you are getting it. You don't have to externally do it. And then what happens, guys? Look at it from diagram perspective. Let's say you created your Spring Boot application. Let's say first app, your Spring Boot application you created. In order to run this application, okay, you're basically activating a Tomcat server. So Tomcat server is activated, which is going to process your web request. Okay, so your Spring Boot application basically runs inside this Tomcat server. And this kind of server is designed to basically receive a request from you, which is nothing but a web request. Web request from you. Web request is nothing but what? HTTP request from you, because HTTP is the protocol for our communication of web APIs. So it will receive HTTP request. Next, Spring Boot is having some framework code. Because of that, this HTTP request, which comes to the Tomcat server, will further reach out to the Spring Boot related code. This is how it works. So for running your Spring Boot application, we run the Spring Boot application inside a Tomcat server. It is by default happening. Whenever any external request comes, it first is caught by Tomcat. Then Tomcat gives this request to your Spring Boot framework code. The jar file which you have added, ready-made code jar file which you have added, that is going to take jar file, ready-made code, and then comes your application code. Maybe you will write your controller layer, service layer. This Spring Boot is going to give the code call into your application code. Are you understanding it? How the code arrangement is? We will write this application code, which is nothing but your layered application. But in order to call your layered application, let's say your controller and service and other things, that call is going to happen from Spring Boot related code. We discussed sometime earlier, we need a capability that other people can reach out to us. How is that possible? Okay, Tomcat plus Spring Boot work together to make that happen. Okay, so a server is required to run your web application. So Tomcat is used for this purpose. Whenever an external request is coming, first Tomcat catches that request. Then Tomcat says, okay, I need to give this to internal guy, which is Spring Boot related code. And then Spring Boot takes it and identifies, I should give it to the controller, which is written by the developer. And this is the flow of execution. Think logically. If Spring Boot is not available, this method call will not happen. If Tomcat is not available, this method call will not happen. Without these two, you are basically building standalone application. Here, Spring Boot with web capability we added, so it is doing web related processing. You need to understand, Spring Boot can be used for standalone application also. Just say if you go to start.spring.io and if you don't choose any dependency, you're building a standalone application. So using Spring Boot, web applications can be created, standalone can be created, cloud-based can be created, reactive can be created, microservice can be created, Spring AI can be created. So Spring Boot is like, can do everything. Depending upon what you want to use, we are using it. Today, we used it for web. In web, how it works? First, the request comes to Tomcat. From Tomcat, because of Spring Boot web, the request is caught by Spring Boot and then it comes to you. What does it mean because of Spring Boot web? It means there are jars added in our project which is designed to receive an HTTP request, and it can understand how to give it further. That kind of intelligence is running in our application today. Concept is simple, but if you don't understand these things, you will never enjoy IT industry. Setting up this kind of project is like 2-minute job. Writing a controller is like 1-minute job. But if you don't really understand what is what and why, and the magic, just a jar which is so powerful, which can connect an incoming HTTP request to your controller, that's actually magic. You will get goosebumps if you really understand what IT industry is. 30 years old industry, guys, more than 30 years old industry. And we are building softwares which is changing the face of the world. AI and all is completely revolutionizing the full industry. Brilliance is there in the IT industry. So be proud that you are coming here. It's not just any other job. You need to be passionate about, yes, I will understand all this. And that is beyond just regular simple coding. It's about understanding concepts. It's about designing. It's about thinking. It's about logic. It's like waking up in the morning with like sparkle in the eye. Okay, today I will build something new, right? And your journey as a job seeker should also be like that, because you're learning new things every single day. When you get good amount of knowledge, do the job hunting aggressively, industry will give you job. But wake up towards this beautiful industry, not like scared. I'm not getting. Learn. Those who learn, those who become good, those who achieve greatness in their knowledge, they succeed. Remaining people will stay worrying, crying, blaming, complaining. You need to understand the essence of what IT industry actually is. It's not just a job. It is a dream to build something great and create magic with your hands. It needs you to understand design. It needs you to understand like how this beautiful system of internet works, how the request can pass, how the data can be passed, how can you receive the request, how can you make logical pieces in the system, how can you build modular, scalable application. And that's magical, basically. Passion is required for IT industry. It's not just any other regular job. It's passionate people. Brain job is there. Brain job, right? Amazing. Fine. Anyways, 15 years I am here. I've seen magic happening in front of my own eyes. I've seen passionate people, and that keeps inspiring. Okay, wow, what a beautiful industry this is, right? So welcome to the industry, but you need to gain knowledge. It's not just a dumb job here. Fine. So this is what is the flow. So what has happened? When we are running this kind of a command, I think my words might touch some of your hearts. And if it has inspired you, get passionate about the industry right now. Stop complaining, blaming, learn, upgrade, hunt job aggressively, and keep doing that daily till the time you get job. Results will be in front of you. Okay, so what have we done so far? We have ran this command, clean Spring Boot. We have ran this command, clean spring-boot:run, and our application is started. But now we learned some more things. What does it mean application is started? It means Tomcat server is active and it will receive incoming request. It means Spring Boot is active, that when a request comes to Tomcat, Spring Boot can capture that request. And it means if a developer has written any new code properly, Spring Boot will hand the request to developer, then you run the code. That is what it means. And now I think these logs will start making sense to you. Tomcat initialized with the port. It is starting the Tomcat server. Tomcat is given by Apache company. And then, yes, Tomcat is successfully started on 8080. And our name of the application, which has led to all this Spring Boot to come up, it is finally saying started first application in around 3 seconds it took to bring this full system up. So the starting class is first application. When this main method runs, this line is taking the class which is annotated with @Spring Boot application, and that internally is doing the full magic and system is getting started. Tomcat is activated and all the Spring related world is activated, containers, beans. We will discuss it all later, but the full Spring system came up, Spring Boot system came up, and now we are further ready to receive any incoming request. Okay, let's understand the next point. Let's understand the next point. Our current system, Tomcat is up, Spring Boot is ready, and that's it. Okay, now external guys can try to connect to this Tomcat and your Spring Boot application. External guys can try to connect to your application. Okay, how is it possible? How can you connect to Tomcat server? How can you connect to Tomcat server? How can you do that? In order to connect to any server, two concepts are required. Okay, where is the server running? Second, what port it's running on? Let's say if there is an external guy, that person wants to connect to this kind of server, they need to know two things. Okay, where is the server running? Nothing but maybe IP or domain. Where is the server running? Okay, second thing is what port it is running upon. Next, when you run the server in local machine, when you run in local machine, you call it localhost. Localhost is the alias name for my local machine. Or you can put it with some IP 127.0.0.1. These two things will define my local machine. If you run these two things from your local machine, it is going to point to your machine. So it's not like if I use localhost, it is me. And if you are using localhost, that means my machine. No, no, no. When you, it's like I. Okay, I. When I am using the term I, it means me. When you are using the term I, it means you, right? I. You are also calling yourself I. Like that, localhost means when I use the term localhost, means my machine is localhost. When you use the term localhost, means your machine is localhost. So that is what this is about, right? So where is the server running? Okay, server is running on my machine right now. So I can call my machine as localhost machine or with this IP, it both works. And whenever the server is running, it occupies certain port. Where is this port? Okay, it's simply mentioned here. Logs are clear. Logs are there to tell you to read. You don't know it, you read. Okay, Tomcat started on port 8080. So we need to understand a default port for Spring Boot application is 8080. So two things. Whenever any external guy wants to communicate with this, it needs two information. What is the IP? What is the port? And now comes, okay, protocol. Okay, how can an HTTP request be formed? Okay, so now comes the syntax of the word. First is protocol. HTTP : // So this : / is syntax. This is how the world connects. First you specify protocol, then : // next IP or domain of your server. So in our case it is localhost. Next syntax is : so here : which port your server is running on. Our server is running on 8080. So when you specify something like this, you're basically saying, okay, in my local machine, there is something running on 8080 which is serving HTTP request. Please check, is something like that available or not? So if you want to connect to Tomcat, okay, what it says, Tomcat started on port 8080. Where? In my machine. Using HTTP protocol, we can connect to Tomcat. That's the language of programming. Human language, you just take a phone, you call each other. Okay, how do you talk to Tomcat now? It's a software. How do you talk to software? You need a protocol. You need to know where the software is and on what port it is running. It's a communication with a machine. Are you getting what you're doing here? It's not syntax. It's you're trying to talk to a machine here, web, across web. You're sitting in your home and you want to make a call to Tomcat. What do you say? Oh, where is Tomcat? It's running on so and so IP. Okay, what is the port? And now when you do this, Tomcat will receive your phone call. Okay, this guy is trying to reach me out. It's the beauty about technology. Now you can take this kind of a request. We did not code anything, and you just go to the browser and just launch this. This is not syntax. This is like, okay, you are guiding the internet world that in localhost on 8080, something is running, which is serving HTTP. Take me there. It's a direction you're giving. And when you give this, something came in front of you. Now, people might say, again, as a junior, you are like, oh, this is an error. No, this is not an error. This is success. You reach out to Tomcat and further nothing happened. So it gave you an error page. Okay, for example, let's say you go here, 8081. Now, what do you call this? So this is, when you go to this doesn't mean it's an error. It means you successfully connected and you got a response. If you go here, you were not able to do. But what it means, in the local machine 8081, there is nobody listening on HTTP port. So don't draw wrong conclusions. This is success. We were able to successfully reach out to Tomcat. Internally, we did not write any code. So further it went for a toss, but we were able to successfully connect, because if the Tomcat would have been down, let's say you stop the Tomcat. If the Tomcat is down and then you do this, so then you do this, you are not getting anything. So try to interpret what is happening. Try to think what is happening. When certain thing is working and certain thing is not working, develop this logic to understand, oh, to what extent it is working and after what it is not working. Don't blindly say it's not working. But some part might be working. Can you figure out till what time it worked? Were you able to reach to Tomcat? Were you able to reach to Spring Boot? Were you able to reach to your controller code? And did you process the request? And in the response, did you fail? Because everything is a journey. That's what coding is about. Failure can happen anywhere. Maybe the protocol is wrong. Maybe Tomcat is down. Maybe the Spring Boot configuration is the problem. Or maybe your application code is a problem. One request, multiple failure points will be there. You need to develop this intelligence to understand till what point it is working and what is really not working. Develop that sense. Things are simple, but don't take it bookish. Don't do it like school student. Okay, call this request and then if it is happening like this, it means no. You need to understand. We are in a beautiful world of IT industry. You need to visualize it in the mind. When I give a request, what it actually means when you pass a request like this. What it actually means. It means that in my machine, localhost on 8080, some server should run which should process HTTP. If that is not happening, forget about what code you have written. You will never get anything. And that is what is happening here. Next, you bring this server up now. You bring this up. How do you do that? Another way to start your Spring Boot application. Right click, run as, simply say Spring Boot app. So one is Maven way. Another is direct shortcut by ID. Run as Spring Boot app. It will also start your Spring Boot application itself. When it started, again, it is telling you Tomcat started on 8080. That means Tomcat is up. When Tomcat is up, yes, your application can connect again. Okay. Further, we have not given instructions to Spring Boot. What should happen if this request comes? We have not done that. So it does not know what needs to be done. You can simply give one instruction. Okay. For example, let me show it to you. This is the last topic, then we will take the attendance and close the session today. Tomorrow, we will continue with the next experiments and the remaining work. Okay. Let's say we go to SRC main resources. Under static folder, I'm adding a new HTML file. This is only for experiment. We don't really need this. I'm adding index.html and you go here. Hello, October 25 team. Hello, October 25 team. Okay. Generally, currently our Spring Boot application is in such a shape that whenever you make any change, you have to restart it. Tomorrow we will change that. Whenever you are changing, it should auto restart. Something called as DevTool dependency. Tomorrow we will do that. Currently our situation is you make a change, you need to restart your Spring Boot application. So we will stop this one. Third way to run the last command. Whatever is the last command that you have used, it will be saved here. You just click that. So these are not shortcut ways to run your Spring Boot application. So you don't have to every time keep typing that command, clean spring-boot:run. You can sometimes do right-click run as Spring Boot. You can sometimes just take the last executed command and run that. It will happen. Now we come to this place, 8080. Okay, now you go back to the browser and then try to refresh it here. Hello, October CT team. What's happening? Now you are understanding how the framework is working. Earlier also it was working, but what it is basically trying to do, when you try to call something like this, it internally, by default, if you have not run any other implementation, it by default tries to look for under static folder index.html. And it is showing that on the screen. Whatever is the result of this one, index.html, it is showing on the screen. Basically, we don't need to write this HTML, but at least to see that, okay, now things have happened hand in hand. Okay, what has happened hand in hand? Okay, the work has happened something like this. When you gave this, the request came to Tomcat. The request came to first Tomcat. If Tomcat is down, nothing works. So first Tomcat should be up and running on 8080. After that, the request was not having anything in ahead. So it basically assumes it's a root request with nothing ahead. So it generally takes it like only a slash empty request. And now it tried to hand over this empty request to Spring Boot application and asking, yes, Spring Boot, the input guy has basically not given you anything. Do you have something to process? Spring Boot is now checking what kind of code has the developer done in your this place, in the this place, and we have not written any code here. So Spring Boot is saying, oh, there is no Java code written for this. Let me see if something is able to find. And then Spring Boot realized, okay, if nothing is directly available, I should look for index.html. Internally, Spring Boot code is having that. And then it goes and then looks for index.html, and it's able to take it and able to give it back response, and the response is coming back to you. So now you can control. Currently, Spring was able to reach out and do that. Okay, let's try an experiment. Okay, we are saying right click, run as, or let's say refactor, rename, I will say temp_index. Okay, save this, stop it, start it back again. Okay, let's try to go here and then try to do this. Oh, not this one. Go here, do this. Okay, what is happening? Error page. So that means there is intelligence in Spring Boot now. Spring Boot is saying, okay, if index.html is available here, then I will render that. That's the default behavior. If some other you are putting, it's not recognizing that. So now you want to write your Java code. We said we need to write in PayPal system, we need to write our own Java code, which is going to further talk to the PayPal system. It is going to be some method like this. So understand, currently Tomcat is active, it is receiving. It has handed over to Spring. Now Spring is looking in the code. Is there a method I can call on this input request? Currently, it's not able to find. So accordingly, it says, hey, it's an error. I'm not able to find anything. Okay, you give it an index.html. It realizes, okay, for this slash, I will directly go to the index.html, render that. You don't give that, you don't give any other code, basically it is just failed. So now our next aim is Spring Boot needs help from us. Our next aim is Spring Boot. Okay, you need to tell Spring Boot that for an incoming request, call my method. And how do you do that? Is with layered architecture, which we discussed today. Controller is the entry point. So we need to define a controller so that Spring will understand that whenever an incoming request is coming, I should look for a corresponding controller to hand over the request to the application. And then the layered application will take care of the rest of the flow. Okay. So for today, we would end here. Let's take an attendance, but make sure you understand it. It is not just syntax. It is not just you mug up. It is something which you really understand how the world works, how you can connect, how you can execute, and to what extent the code is working and what is not working. Develop that intelligence. Fine. Let's take the attendance for today, and we will be completing the today's session. In the WhatsApp group, all the details will be further shared, recording and other things. So let me first take this attendance. October attendance. Let's go here. Just observe. Yesterday, around 1,774 members have marked attendance. Okay. So yes, people are watching it offline. Some are live, some are offline. But the point is, listening is step 1. Then practical is step 2. And 100% clarity should come on the topic so you can explain everything to interviewer. Okay, fine. So practice is the key. Today, practical tasks are there. Technical concepts you need to understand, practical. Tomorrow also practically things are going to happen. So again, very interesting session tomorrow also. A lot of new things we will discuss. Okay, fine. Let's go here and let's complete the today's call. So attendance code for today is 7777. And here is the attendance link. Please mark this up, guys. And if anybody of you is not part of our WhatsApp group where the recordings, notes, and other updates are being shared, so you can join the WhatsApp group here. If you're already part of any of the group, it's okay. But yeah, otherwise this is the WhatsApp. Fine. Thank you everybody for your time. 3 hours just passed by. When the topics are interesting, your mind evolves. So don't think what the social media is saying. Okay, people are getting, just because of shorts, their mind are getting shorts attention span. No, that's not the thing. Okay, point is, if you are interested in something, even 3 hours are interesting for you. Fine, social scrolling reels might make it 30 seconds. But because you're interested in like that, you're interested in now a 3 hours topic, your mind expanded your horizon to 3. So important thing to understand is what you are actually interested in. That you will double down your efforts, and that's the power, greatness of humanity. What you are interested in, you will devote yourself. You might not eat food tonight. You might sleep late tonight because you're interested to succeed in this IT industry and you want to get a job. If you're not putting that effort, means you're not that much interested. So you need to look at what you're interested in. The people with dreams, for them, nights will become sleepless because they have a big dream to make reality. So nobody is lazy. Point is, people are not motivated enough and inspired enough to overcome that laziness. So develop that skill in yourself. If you want IT, develop the passion to wake up in the morning and work your best self out here. That's where life will become interesting. Thank you everybody for your time. See you guys tomorrow morning, 10 a.m. with the day 3. Again, technical continuation will happen of what we have seen today. Fine. Thank you everybody. See you tomorrow. Bye team. Take care of yourself. Bye-bye. 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 Stopping the stream. Bye guys.